there is a spectrum crunch, and I think the spectrum crunch this year is different than the spectrum crunch a decade ago. When we went from 3G to 4G, it was cool, we got better phones and all. Now when we look 4G to 5G, what we see is that spectrum and 5G isn't just a matter of better phones. It's probably going to be the engine for innovation in the next 10 years.
The demands for spectrum are going to continue to increase on both the military and the civilian side. And this is driven, of course, by a lot of the technological advances we're seeing, things like 5G that are going to bring even more opportunities for advances, for services, and the military and the civilian world both want to take advantage of those capabilities. So we're going to be wanting more and more spectrum, and the worlds are colliding.
If we continue on our current course, we're going to have problems powering our wireless future. But if we can find new ways to be creative with spectrum policy, I think we're going to see a lot more innovation in the days ahead.
So spectrum sharing has become an acceptable framework. What we now need to do is to put a lot more technology behind it, because we're still uncracking only a small fraction of the true potential of the spectrum to carry information.
The dynamic spectrum sharing concept, the ability to really effectively and efficiently use spectrum so that we don't have broad swaths of it being unused at any given time, that's going to allow us to have more users, more services, more applications, and it's going to let the coexistence of different users and different functions without interference.
So creating scalable spectrum, we think about shared spectrum, but creating scalable spectrum where people can innovate, try something out, get a little more spectrum, expand it, and ultimately grow their business is the secret to bring what made Silicon Valley so successful and bring that into the wireless space.
This is a big paradigm shift for policymakers and technologists, but I think spectrum sharing represents the future.
There is no future for wireless if we can't unlock the value of spectrum.
Is there hope? Is there a path forward? Of course there is. It's innovation, and this challenge is a part of it.
So now's the time for a change.
Ladies and gentlemen, please welcome former host of TV's Mythbusters, Grant Imahara.
Good afternoon, everyone, and welcome to the Spectrum Collaboration Challenge Championship Event. What we've just witnessed is a wake-up call about a looming crisis in wireless. Wireless connectivity is sewn into the very fabric of our society, but we're currently on a path where we'll soon outstrip the lifeblood of wireless connectivity, the spectrum. 3 years ago, DARPA announced a call to action for innovators to reimagine how we access the spectrum. By combining advances in artificial intelligence, autonomy, and software-defined radio, they've created a groundbreaking new kind of radio to address the looming threat of spectrum scarcity. All the competitors that jumped to this challenge had to answer one simple question. How do you create a radio that thrives in a world without the protection of the FCC? Today, these teams, and all of us, will witness the culmination of years of hard work as their autonomous radio designs compete on this stage in a virtual arena created by DARPA for a $2 million grand prize. Without further ado, let's meet our teams. First up, the winner of the 2014 DARPA Spectrum Challenge, a researcher at Oak Ridge National Lab in Tennessee. Put your hands together for Team Anderson, Team Anderson's Adam Anderson and Brett Witherspoon. Next up is a 9-person team from Drexel University in Philadelphia, bringing their Drexel Dragon's Pride to SC2. Let's give it up for Team Dragon Radio. Here with us today from Dragon Radio, Kapil Dandekar, Alex Lockpour, and Jeffrey Mainland. And now a 3-person team, whose namesake is the Greek god of stealth and shadow. Does that give us a clue to how they'll navigate Spectrum? We'll find out. Let's welcome from Rochester, New York, Team Erebus. Team Erebus is Brent Josephic, Brian Padalino, and Russell Eller. Our next team brings together professors, undergrads, and PhD candidates from the University of Florida and proudly flies their Gators colors. Let's hear it for Team Gator Wings. Tan Wong, John Shea, David Green, Tyler Ward, Caleb Bowyer, and Marco Menendez. And now a two-person team. These cybersecurity experts, now radio hackers, came to the competition over a year later than most teams and battled their way to the top 10. They hail from both San Francisco and right here in Los Angeles. Please welcome Mark Newland and Matt Knight of Team How Make Radio. Next, we have a four-person team of former and current Vanderbilt University researchers, all originally from Hungary. They're named after a sleepy little animal, but don't let that fool you. They placed first and second in the two preliminary tournaments. Please welcome Team Marmot E. Marmot E is Peter Volyeshi, Miklos Marodi, Peter Horvath, and Shandor Silvashi. And now our largest SC2 team, with members scattered across the globe, from IMEC in Belgium, Ghent University, University of Antwerp, and Rutgers University. Please welcome the aptly named Team Scatter. Ingrid Moorman, Stephen Latry, Ruben Menez, Miguel Camelo, Ivan Seskar, Dragoslav Stojadinovic, Spilios Yanulis, Irfan Yabandic, Adnan Shahid, Prasanti Madala, Michael Mihan, Carlos Donato, Yorick DeBoek, and Jakob Streya. Next up is a one-man team, a new kid on the software-defined radio block who came to SC2 with no prior wireless experience and quit his day job to battle his way to where he is today, among the top 10 wireless teams in the world. Give it up for Malcolm Stagg of Team Sodium 24. And now from Northeastern University in Massachusetts, a collaboration of students and professors who bring their talents together to make up Team Sprite. Put your hands together for Team Sprite and their members here today. Dr. Guvara Nubir, Hai Nguyen, Teen Vohu, Norbert Ludant, and Marinos Vombas. And last but certainly not least, the winners of the SC2 final qualifying event last December, a two-man team from Atlanta. You can bet there's a target on their backs today. Put your hands together for Bob Baxley and Roy Thompson of Team Xylinium. And now that we have our teams in place, it's my pleasure to welcome their Chief Taskmaster and head of the Spectrum Collaboration Challenge, DARPA Program Manager, Paul Tillman.
Hi, Paul. Hey, Grant. How you doing?
Excellent. Okay, Paul, first things first. Tell us all about DARPA.
All right, Grant. So DARPA is the Advanced Research and Development arm of the U.S. Department of Defense, and it's tasked with the mission of creating and preventing technological surprise. We're known for transformational changes. We don't focus on what's now. We focus on what's next. But we're perhaps best known for technological revolutions like the internet, miniaturization of GPS, autonomous vehicles, stealth, voice recognition, and the list, of course, goes on and on.
And why have you chosen to have this competition at Mobile World Congress?
You know, Grant, like self-driving cars, sometimes the problems that DARPA tackles lie at the intersection of the commercial and the military worlds. And the spectrum crunch that we're talking about today is an example of just such a shared problem.
Now, has this problem been around for a while? And why such an emphasis on finding a solution right now?
You know, Grant, DARPA has actually seen the writing on the wall and the need for spectrum sharing for almost 2 decades now. But the emergence of 5G has really brought the urgency of this problem into the spotlight. A real challenge that we find ourselves settled with right now is answering the question, what spectrum will 5G use? Now, I'm not talking about new greenfield millimeter wave spectrum. I'm talking about good old-fashioned low and mid-band frequencies. Simply put, all the easy answers to this question are gone, and there's really no more low-hanging spectrum fruit.
So, are you saying that we're at an impasse with 5G?
No, certainly not. I have no doubt that after long, hard deliberations, our policymakers will find a way to reshuffle the spectrum, make the old system work, and make way for 5G. But it will be an arduous path filled with the kinds of decisions that have only grown more and more contentious. DARPA is taking on this problem because spectrum is a finite resource. And with both commercial and federal wireless use growing exponentially, our 2 worlds have been thrust together. We can no longer afford to separate the world into commercial spectrum and federal spectrum. At the end of the day, it's all just spectrum. So we need to get onto a new path, and we need to do it together. Find new technologies that enable us to share and maximize our use of this precious resource.
Now, I think many here, like me, are hoping for some kind of a game changer. How does SC2 represent a rethinking of how we manage the spectrum today?
Great question. So let's start first with the notion of spectrum sharing. Spectrum sharing comes in lots of different flavors, but at its core, it's the concept of taking a single radio band and using it by multiple types of radio systems. Now, we can do this in a coarse fashion, where we take turns sharing over long time scales, let's say days or even hours. Or we could share dynamically on a time scale of seconds. The faster the sharing, the more efficient you'll ultimately be. And the potential of the wireless spectrum is so much greater than we're able to achieve today with our current exclusive allocation and core spectrum sharing approaches. So, here's the vision of SC2 in a nutshell. What if we didn't have the safety afforded to us today by the FCC? Could we make radios that are smart enough to be able to manage the spectrum all by themselves? Now, Grant, let me ask you a question. If I told you that to win this competition, all you had to do was to build a radio system that could share the spectrum with one other kind of radio, what would you do?
Oh, you're asking me? You're going to put me on the spot here, Paul?
Oh, I am.
I am an electrical engineer, but I build robots. I'm not a wireless guy.
Come on, Grant. I think we've all seen you make tons of remote-controlled things. You rely on spectrum as much as anybody in this audience. Come on, tell us. Where do you start?
Okay, fine. I'd want to know what kind of radio I was being asked to share with.
Okay, this is a great question and a great way to answer it. So, good start. It's exactly what we would do today. But technology is growing so fast, so let's make it tougher. Now you're sharing with hundreds of radios, and you don't know who they are, and you don't know how they work, and oh, by the way, they don't conform to any one standard. They're all kinds of different technologies. So what do you do now?
All right, well, since I can't know anything about the other radio systems in advance, I would use an AI, as we do in robotics, to have my system learn how all the other radios are, how to share with them and adapt on the fly, no matter what they are.
Perfect. This is exactly what we need to do. But here's the challenge. AI needs feedback. If you're going to learn and adapt on the fly, you need to know when your radio causes interference and when it doesn't. Wouldn't it be nice if the radios could collaborate and get this kind of feedback, Grant?
And this, I suspect, is where the collaboration part of our competition comes in.
Okay, fair. I was leading the witness just a skosh. But it's a really important point, folks. Different wireless networks today don't collaborate. They don't share information. And of course they don't. They don't have to because we, humans, keep them in their own lanes. But if we're going to share, and if we're going to do it dynamically, feedback, that is collaboration, is paramount.
Now, I'm sure many here are wondering why DARPA just doesn't hire a team of crack A-list wireless experts and have them sort this out. Why a competition format?
Okay, so grand challenges like this are actually a really special thing at DARPA. The name and much of the original heritage comes from the original DARPA Grand Challenge.
Yes. Actually, as a matter of fact, I was involved in the 2007 Grand Challenge competition.
There you are.
That brought, there I am, that brought self-driving cars into an urban environment. And today, they're literally everywhere.
That's right. So a Grand Challenge really has to strike at a problem that's not just hard, but has broad ramifications, and not just militarily, but societally. These are problems where we don't have a clear solution, but rather some array of possibilities where a competitive gauntlet will bring the best ideas to the top. Lastly, challenges are about breaking paradigms and building communities. The state of the technology at the end of a competition like this today will be really raw. But it will require additional years of development time. The community, however, that we build will live on long past the end of this competition and is going to build on the momentum that we create here today.
All right, Paul, can you give us a rundown of the technology approaches our competitors are using?
Oh yeah, I would love to. Okay, so the teams here represent the top entrants from a field of over 30 plus teams going back 3 years ago when we started this competition. They've come an incredibly long way, and looking at the group here, they really represent a really wide cross-section of different approaches. So we've got some teams that are betting that a modified approach to an existing wireless standard like LTE is the way to go. We've got other teams that have actually built waveforms from the ground up, especially for this competition. But at the end of the day, this competition really boils down to a battle of the decision engines. You could think of that as how each radio decides to navigate the spectrum.
Okay. Let's talk about how our teams are using AI.
Okay, this is great. So some of our teams are tackling this as a mathematical optimization problem. Some are using good old-fashioned expert systems. Some are trying their hands at applying modern machine learning and reinforcement learning approaches. The competition that's about to take place right here will ultimately tell us which of these types of approaches will carry us forward into that next generation of wireless, Grant.
Just how difficult a problem is this for an AI?
You know, humans have been building AIs to do things like play games for years, starting with chess and then eventually graduating to Go. And as the games get steadily harder, there's an explosion in the number of possible moves that it could take to win the game. Now, for SC2, this really goes to yet another level. Because every individual radio can make its own decisions, there's effectively an infinite number of moves. So this is a really challenging problem, Grant.
How did you go about setting up this whole competition?
Okay, so got to put yourself in my shoes. 4 years ago, we're thinking up this competition. We needed a way to have tens of dozens of radios, all of different kinds, interacting, moving through time and frequency, and of course space, in a multitude of environments. Oh, and it all has to be repeatable, of course. So we really quickly saw that trying to put actual hardware, that is radios, out into the real world, outdoors, was just never going to work logistically. But we realized that with enough computational power, we could actually build an arena, a battleground, that would make our competitors' radios appear as if they were in the real world. But to do it, our arena would have to be the world's largest wireless emulator. Now, all of you here walked past it as you entered the theater. Coliseum is the SC2 battleground. It's a radio testbed that lives in the cloud. And for today's competition, we picked Coliseum up from its moorings back in DC, and we rebuilt it here on the LA Convention Center floor.
Now, I'm pretty sure it would have been hard for people to miss Coliseum on their way in. But for those who haven't seen it up close, we have John Chapin waiting to give us a peek inside.
Great.
Hi, Grant. I'm inside the Coliseum enclosure. It's pretty loud in here. The roaring sound you hear is the cooling equipment for over 3,000 tera operations per second of computation and over 52 terabytes per second of streaming data. In order to see just how big this machine is, I need to take you outside the enclosure. In fact, it's so big, you can't see the whole thing from ground level. You have to look from the catwalk to see just how big Coliseum is. Let's look closer. Each of the racks of equipment in this enclosure has a specialized function. The first one is just the computers that control Coliseum. To the right are 2.5 racks of servers This is where the software written by the competitors runs, the AI decision engines and the networks. At the bottom of the third rack are the software-defined radios. These do the transmission and reception for all of the competitor network nodes. The output of each of those radios, the antenna, is connected via these blue cables to the ports on the channel emulator. The channel emulator is the heart of the system. It is virtual reality for radios. We can make these radios think they're in any environment, moving however we want. We do all the computation in real time about how they interact with each other and with that environment. It takes a lot of computation to pull that off. Put 4 of these together, and you're doing about the same as if you were streaming 83 million high-definition TV channels at the same time. Back to you, Grant.
That is amazing. Thanks, John.
You know, Grant, fun fact here. None of these teams have actually seen Coliseum before this week. For the last 3 years, they've lived inside of Coliseum. They've run over 130,000 experiments, but they've been doing it all 24/7 remotely via the internet. So I'm sure this is really exciting for them to get to see it up close.
Well, all right. I think it's time to get this competition underway.
I do too.
All right. The SC2 Championship Event is comprised of 2 parts, a round-robin elimination and a live head-to-head finale. The DARPA team analyzed more than 200 matches to get to this point today. For the first time, we'll reveal the results of the round-robin elimination. Then we'll go live to the Coliseum for the final round matches. The teams will be watching, helplessly, from the competitor deck as their radios battle it out in the Coliseum, unassisted and completely autonomously. We start the competition off with our 10 teams in round 1. After each team has performed 40 matches where each match tests the ability of 5 randomly chosen teams to share the spectrum, the lowest 2 ranking teams go into the elimination match. The higher scoring team in the elimination will get to live on to fight another day and move on to the next round of play, while the lower scoring team will be eliminated and their journey in this competition will come to an end. The remaining 9 teams will then have their slate wiped clean, all scores reset to 0 heading into round 2. And again, the bottom 2 ranking teams will face off in another elimination. After 5 rounds of play, only 5 teams will remain standing, headed into the final round.
All right, Grant, now we should also tell the audience here that in each of these rounds, we will introduce a new scenario, with each scenario testing our teams against 5 distinct criteria that are required for successfully demonstrating their collaborative intelligent radio networks can indeed thrive in this world that we've created without the FCC. So we'll test them for stability. Radios need to deliver a stable user experience despite the fact that they're sharing spectrum. We'll test their ability to find opportunities to reuse the spectrum and maximize its potential. We'll challenge their ability to prioritize. Radios will need to make way for high priority traffic in the shared spectrum. We'll challenge their ability to handle surges. Radios will need to continually adapt as the wireless demand ebbs and flows. And last but not least, we'll see how they do at handling congested environments. Radios will have to compete to maintain a stable service as our wireless environment gets more and more congested.
Now, in the final round, the top 5 competitors will face amped-up versions of some of these challenges in a series of matches. And there's more than the future of radio autonomy at stake here. The third-place team will take home $750,000. The second-place team, $1 million. And the first-place team will win the $2 million grand prize. So let's take a look at a Coliseum match. And to help us with that, I'd like to welcome to the stage President of GNU Radio, the world's largest open-source software-defined radio community, Director of Engineering at wireless and AI startup DeepSig, and our match announcer for this event, Ben Hilburn. Joining Ben is a key member of the DARPA team will be driving Coliseum from our stage, Craig Pomeroy. Okay, take it away, Ben.
Thanks, Grant. So before we dive into our first match, I'd like to take a couple minutes to acquaint everyone with the visualization tool that was custom built by DARPA specifically for this competition. Now this allows us to really not only analyze these matches, but actually understand what's happening. And it's worth noting that this kind of thing is really only possible because of the technology that was created for SC2, like Coliseum, and it really fundamentally represents a new way to understand spectrum collaboration. Craig, can we go ahead and come up to your computer here? So there's a tremendous amount of capability within this tool. This is really going to be more of a brief crash course. You can see right away, right, we can look at multiple panes at a time, each showing different types of information. We're going to look at each one individually as we get oriented here. So first, we're going to look closer at what is actually happening within a match. Craig, can you go ahead and take us into the spatial view? So here, we can actually visualize the simulated world where these radios are operating. And at the bottom is what we call, the time scrubber. This allows us to move forward and back through time within a match. Okay, can you just pull us back or push us forward? And as we do that, right, we can see the radio nodes moving through space within this match. Now, the radio nodes are color-coded. So these, for example, are a lot of radios sitting on top of each other, but they're clearly yellow. So these are radio nodes from the Airbus team. Now, Craig, can you pull us out? And we're going to look at the spectrum. So this is a God's eye view of everything happening in the spectrum over all of space. So in this particular match, there's 50 radios, and we're looking at what every single one of them is doing in the spectrum. So this is really only possible because of Coliseum. This isn't the view from a single receiver somewhere in space. We can actually see what all of them are doing. This represents the full bandwidth that these radios have to operate in with this scenario. So if you think of this as the center, this is plus or minus 10 megahertz. So this is a 20 megahertz scenario. Now, Craig, can you start playing time? So time scrolls from right to left. So the right side is the current time that we're looking at within the match. Now, once again, you can see what's happening in the spectrum based on color. So up here, for example, we see pink energy. That would be something that's being transmitted by the Andersons. Now, we can look at them all at once, or we can take finer grained views. Craig, can you maybe just show us Airbus, for example? And just show us Dragon Radio, brown. And further, we can actually look at more than just time and frequency. We can actually look at power. So Craig, can you actually pivot our view and sort of zoom us in here? Okay, so from views like this, you can see what's actually happening from the perspective of power. So here, for example, I'll draw a line at where Dragon Radio's power caps out, and you can clearly see that Erebus is substantially below it. So here we're looking at Erebus transmitting more energy than Dragon Radio. Finally, Craig, can you come back out, and we can change the time span that we're looking at within the match. So Craig, can you perhaps expand our window so we can zoom out in the spectrum, and if you compress it, it has the opposite effect where we can zoom in and see more finer-grained time blocks about what's happening. So now, can you pull back the right side for me, Craig? Now, this is the current time boundary. So to the left of this are things that have already happened, where we're sitting here in the match. To the right is the future, well, where nobody has transmitted yet. But we can actually look at the conversations that the radios are having about the future. So Craig, can you turn on the collaboration channel for me? And we're going to look at this in more detail as we start diving into matches, but this is especially important. So here, for example, we see Cyan scatter, forecasting to the rest of the ensemble, hey, we're going to use this little small bit of spectrum, and we're telling you about it a little bit into the future. Whereas Anderson's, for example, is saying, hey, we're going to use this entire top chunk of spectrum, and we're forecasting that for as far as we're looking at right now. So we've sort of gone over what's happening within a match. Now we should talk about how do you win the game? How do you score points? Craig, can you pull us back out of this and take us to our applications view? Perfect. Okay, so this is what we call the applications view. Now, in the bottom, you can see the different wireless applications that are being serviced within this scenario. So here, for example, we see voice calls. These are command and control links for UAVs. This is video links, and this is imagery. Now, if each box represents a single one of those links, if it's outlined in white and sitting at the bottom, that means the team is successfully delivering that data and holding it stable. So they are scoring points for each of these boxes. If a box is starting to fill up, that means the team is attempting to deliver that data, but they haven't closed it yet. If it's completely unfilled, not colored at all, that means the team has been asked to carry that link, but they're currently not attempting it. Now, when a team is unable to hold a link, this is indicative of, you might think of a poor quality of service. So like dropped voice calls or videos buffering. And the different applications have different requirements. Some are more difficult than others, and they carry higher point values. So Craig, can you go ahead and pull us out into our bonus view? Great. So this is actually where we see how well teams are scoring. Can you turn on the maximum points on the right side for me? Perfect. Okay, so here in this scenario, every single team can score a maximum of 41 points per second. This changes by scenario. We'll explain that more as we move on. The green line that you see in the middle is the bonus threshold. As long as at least one team in the ensemble is below this threshold, the entire ensemble scores the same amount of points as the poorest performing team. So Sodium 24, not picking on you, where we've stopped this particular match, Sodium 24 is in the lowest scoring position. They're currently scoring 12 points, which means the entire ensemble at this point in time is scoring 12 points per second. Now, once the ensemble moves into bonus, that changes. Craig, can you take us to a point where we're in bonus? Perfect. So here, the entire ensemble, all 5 teams are over the bonus line, which means they're able to score bonus points based on their performance. So Erebus, for example, at this point, is scoring 41 points per second, the maximum allowed in this scenario. The Andersons are scoring 28. So this is how the teams differentiate from each other in terms of how well they're able to perform. Craig, you can roll it a little bit, and we can see how this works. Thanks.
All right, Ben. Well, I think with that, this is the only time in the show, folks, that I'm going to actually get to take the telestrator, so I'm going to enjoy this thoroughly. I really need to explain the bonus line, because the bonus line is something important, and it really is a key part of this competition, how scoring works. The bonus line that Ben showed you is collaboration. Right? This is what causes spectrum sharing to happen in this dynamic environment. And the way that we should think about this is, let's pretend we move this bonus line all the way to the left. What happens? This is spectrum anarchy. At this point, there is no incentive for these teams to protect each other. There's no incentive to share. They should elbow each other out of the way, take as much spectrum as they can get, and rack up all the points possible. As we move the bonus line in this direction, what we're doing is we're incentivizing sharing. We're causing the teams to actually first ensure that each team is able to score a fair number of points before then maximizing and trying to push additional wireless applications into the spectrum. Grant, over to you.
Thanks, guys. It's time to begin with round 1. 10 teams will be battling it out in the Alleys of Austin scenario. Let's take a look.
We all know how challenging it is to have to wait for a video to stop buffering or for a message to go through. Imagine how critical this is for a soldier. Urban operations are among the toughest for dismounted troops who need stable, reliable communication to optimize their safety. The Alleys of Austin scenario represents a practice sweep of a residential neighborhood by dismounted soldiers and shows how SC2's autonomous radios can provide stable service without dedicated spectrum. Each team's radio network represents a squad moving in formation, communicating back and forth within their squad, clearing the city as they go. All squads consist of 9 soldiers on the ground and 1 drone overhead. Using today's fixed channel approach, a spectrum manager would divide the spectrum into an exclusive band for each of the 5 radio networks to create a reliable service. If the SC2 radios are successful, they must collaborate to autonomously share the spectrum while maintaining a stable, reliable user experience. Throughout the scenario, the challenge for the SC2 radios gets tougher as increasing traffic demands in each stage put greater and greater pressure on the spectrum. There is sufficient spectrum to meet all needs of every radio network. However, as we go from stage 1 to 2 to 3, the margin of error becomes vanishingly small. For the Alleys of Austin scenario, the SC2 radios that create the best user experience with the highest stability will score the most points.
Okay, so something important we have to tell the audience, Ben, before we get underway. We brought Ben in because we asked Ben to help us analyze the hundreds of matches that make up the elimination round. And what Ben's done for us is he's plucked out just a few that are worthy of us sort of diving in and getting a sneak peek under the hood and seeing what the state of the art for our SC2 radios are.
Thanks, Paul. Yeah, so I've spent the last few weeks with Paul's team, and I'm excited to share some of the highlights from the matches that we've seen that really, I think, demonstrate some of the key aspects of the scenarios. So in this first round, each team had the opportunity to play in 40 matches. And as we just heard, what we're looking for here is stability. So in the match that I've picked for us to look at, we've got the Andersons, Marmot E, Scatter, Sprite, and Zelenium. Now, Paul, we're calling this match the Whispering Hulk.
Hulk more sensitive than Hulk is known to be.
That was pretty good, actually.
That was not bad.
Yeah, that was not bad. All right, with that, we're gonna run the match. Craig, can you pull up the match for us and start rolling? Perfect. Okay, so Paul, right off the bat, watch Zelenium and Marmot E. We're just not even 30 seconds into it.
Stability out of the gate.
Locked all of their applications down, and Sprite gets it pretty quickly thereafter, too.
Yeah, they absolutely do. And just to reorient the audience, stability here is seeing the little boxes that chiclets drop to the bottom and stick. If they bounce back up, that's a sign of instability. That's a phone call that you don't want to have on your phone.
So here we're late in stage 1, a little bit of churn, but Scatter also joins them in holding most of these flows stable. This is really good ensemble stability, and it's happening totally autonomously.
Now we just moved into stage 2, where as we heard in the video, things get a lot tougher.
Right, but look at Zelenium and Marmot E, once again nailing most of their applications pretty much right out of the gate.
Yeah, these guys really know how to jump into unplanned spectrum and make the radios work in a very stable fashion. It looks like, Ben, the other 3 teams, though, in this match are struggling to get that same level of stability.
Right, there's a little bit of a revolving door happening here. The Andersons seem to be actually holding some of those links stable before attempting others, which is an interesting sort of quality of service.
All right, we just crossed into stage 3. This is the hardest stage yet, Ben, and look at what's happening here with Marmot E.
Yeah, and I also want to point out, we saw a lot of success from Zelenium in stages 1 and 2, but if you look
now
here...
Now they're struggling.
They're struggling to close anything here. Now, Zelenium's going to bounce back a little bit, but unfortunately in this final stage, which is the most difficult of them, Scatter isn't able to put any points on the board, and as a result, the ensemble doesn't really do well in this stage.
Yeah, so without Scatter scoring points in this final stage, the rest of the ensemble doesn't have an opportunity to really score points.
Right.
So, Ben, let's imagine today I took 5 random radios, I took them off the shelf, and I threw them into some chunk of spectrum like we've done here. We wouldn't see an ounce of stability that we've just seen. We would actually see jamming, interference, we'd see churn. But these teams have used collaboration and autonomy, artificial intelligence, to actually derive a spectrum plan on the fly. And we just saw in the first stage, where things were a little easier, we saw 4 of our teams hit really stable operating points. As things went on, we saw that whittle down from 4 to 2 to 1. But it's clear that we can actually use collaboration and autonomy, Ben, to get stability in shared spectrum.
Right, so actually what I want to do is now go back, since we sort of played through that a little bit quickly, and take a deeper dive on a couple of the points where we did see really good stability.
Okay, great.
Craig, can you take us back into stage 1, where we saw good stability within the ensemble? And what I'd like to do, Paul, is actually walk through what each of these 5 competitors are doing in the spectrum. Okay, perfect. So here, right, we see great stability from Zelenium, Marmot E, Sprite, Scatter, and Andersons are holding those flows stable. So if we look up here at what's happening in the spectrum, Zelenium, you can see, are just sitting right at the band edges.
Yeah, right. And Ben, we've seen this kind of behavior from Zelenium before. This is really sort of an advantageous area in the spectrum to be out at the band edges, because when you live out here on the band edges, you only have to fend off spectrum from one side, not from both.
Right, there's nobody on these sides because they're sitting literally at the edges of what's allowed in the scenario.
Perfect.
And I want to point out, too, that this actually worked really well for them because they were closing all the links and using very little spectrum doing it.
Okay, so Ben, why don't we go on and let's look at Marmony. Let's look at the red team and see what they're doing in the spectrum.
All right, let's pull them up.
Now, Ben, we should mention that Zelenium's design is actually an interesting one because it's centralized and decentralized, as is Marmot E's here. So we see both of these teams actually sort of splitting the decision-making across their network.
So it's probably worth pointing out, by centralized, we mean that there might be one AI making decisions for all 10 radios within the network, whereas in a decentralized network on the other side of the spectrum, to use a bad pun, there might be one AI for each radio. So you have 10 AIs for a 10 radio network.
Right, so in any of these matches, we have somewhere between 5 and 50 AIs all battling it out at once.
Right, so here we see them sort of using a mix of this, and it's doing well.
Right, it's clear that Marmot E here is maybe using, is allowing each individual radio to make a decision on what channel it uses, because I see about 10 channels there, Ben. That's about 10 radios.
Right, and it's clearly a very different channel usage strategy between Marmot E and Zelenium.
Of course.
All right, so let's go ahead and move on and take a look at scatter. Okay, so we see scatter using 3 channels really, and the channels they're using are not only a little bit wider in bandwidth rather, as opposed to the 2 teams we just looked at, but they're also using them more consistently.
Yeah, Ben, so a really interesting thing here about scatter is that they actually built their design up from a existing commercial standard, LTE in this case. So I think those in the audience who know LTE recognize it doesn't look like this, so they've clearly done a lot of modifications, but we'll have to see how that plays out here for them today. Let's go ahead and let's move on and look at the pink team, Team Anderson's. This is the first team that we're going to look at today that actually uses centralized decision-making instead of decentralized decision-making. So very interesting and unique approach here for Team Anderson's, Ben.
Finally, let's look at lime green, the Sprite team.
Ooh, refreshing.
Now, Paul, what's interesting about Sprite is there's not really much of a gap between their channels and the other teams.
Right, so where we saw Zelenium trying to occupy those band edges as a way to minimize interference, Sprite has actually built some special filtering into their radio that allows them to cozy up very close to other radio systems in the spectrum while still trying to sort of tamp down that interference, Ben.
So now that we've looked at what each team is actually doing in the spectrum, I'd like to go back and look at this same portion of the match again, but instead paying attention to what the teams are telling each other in the collaboration channel.
Great.
So again, the collaboration channel is this side, and before doing anything, you can tell right away that Zelenium, right, sitting right at the band edges, is also telling everybody, hey, we're going to sit right at the band edges.
Right.
So this is exactly what we'd expect.
Okay.
So now let's move on and look at what Marmot E is doing.
There we go.
All right, so here's
Zelenium doing what they said.
All right, and now let's look at Marmot E. So
not forecasting as far into the future.
It's
here,
still
but
accurate.
Very accurate.
Still accurate.
Scatter forecasting less far in the future and only using about half the channels.
Right. Anderson's also very accurate. They're using 5, forecasting 5. Sprite also forecasting every single channel that they're using.
All right, so Craig paused this for us at a point of high stability. And to me, Ben, it's really clear that the stability we're seeing is not just a result of the radio designs, but it's also a result of the collaboration. They're making spectrum forecasts. They're telling each other where they're going to move in the spectrum, and that's allowing them to find these stable operating points and behaviors, Ben.
Yeah, so I think accurate forecasting, clearly a major key to stability here.
Of course.
So Craig, Craig, I would now like to bring up the bonus view in the bottom and scrub us forward into stage 2. And then we're going to let it play until about halfway through the stage, Paul. So we're going to see the ensemble is going to go into bonus here. They'll lose it briefly, but overall the ensemble is doing pretty well, right? And yeah, so here we'll see Scatter and Anderson's fall below briefly. They come back up. Craig will pause it for me. There we go. Perfect.
Wow.
Okay. The ensemble's currently in bonus, and they're scoring very well.
And look at how many points Zelenium is. So Zelenium's scoring 66. That's actually maxing out the points right now where we are in this stage. That is quite impressive.
Right. Zelenium's doing great. But let's take a look at what's actually happening in the spectrum. Now, if you're paying attention here, there's pretty much nowhere that you don't see blue.
Yeah, Zelenium is everywhere in the spectrum right now.
They are absolutely everywhere. Now,
they're also telling everyone that they're going to be.
Yeah, at least they're honest about it.
This is very honest.
But Zelenium has told us that they call this aggressive mode.
Yeah, now Zelenium, this is a freebie for you guys. We've been out in LA for almost 2 weeks. We brought in a comedy punch-up team. Let them know what we found, Ben.
Zelenium, we have dubbed this Hulk mode. So, but let's take a closer look at what Hulk mode is actually doing, because the ensemble is doing well.
Yeah, there's something behind this.
Okay, Craig, can you actually pivot our view so we can see power level?
There we go.
All right, perfect. Check this out, Paul. We'll use Marmot E and Anderson's, for example. So you can see the power level, right? Of
the high peaks on these two teams.
Of the Marmot E burst here.
Yep.
And look where Zelenium is. Zelenium is way down here. They're absolutely, I mean, they're everywhere. You see blue everywhere, but it's low power compared to the rest of the ensemble.
Yeah, Ben, I mean, at first this looks like maybe it's not in the spirit of the competition, right? You hear Spectrum collaboration and Spectrum sharing, and the Hulk is currently running down Main Street. But the ensemble is still in bonus here, right? Mm-hmm. So there's a bit of intelligence behind here, because Zelenium understands right now they're able to Hulk out, drop the power, and they're able to do it in a way where they score a lot of points, and they're not taking points off the board for other teams either. They're avoiding interference. Ben, I think obvious why the Hulk is whispering here.
Right. And this is really what defined the match. As we saw before in Stage 3, the ensemble wasn't very successful. It never went into bonus. And so as a result, the leaderboard in this match ends pretty much as you see it now, with Zelenium at the top, sort of hulking its way up there.
Yeah, Ben, so we talked about in the intro that this is really a competition that's about brains, but it really is, at the end of the day, about both, right? As the spectrum becomes more and more congested, it's about both brain and brawn. And I wonder here that by leveraging an existing commercial standard, it seemed like Scatter really struggled in that final stage. And so maybe, you know, by leveraging a baseline that isn't robust to extreme interference like we see in this competition, that may have made things difficult for Scatter. So we're going to have to see how that plays out, Ben.
Well, we can see how it plays out in the remainder of round 1.
Awesome.
Craig, I think we're done with this match. Can you pull us up to the leaderboard? So once again, we don't have a chance to look at every single match. In this round, each team was able to play in 40 matches, and that was the only one we're going to look at. So we're now going to play through the remainder of the matches in round 1 and see the score updates from those matches.
Now, Ben, before we roll that, will you just sort of highlight the cut line here? Because I think it's important to understand that, right? We have 10 teams in this round, but the bottom 2 teams after this round is complete will be headed into our knockout match. So keep your eye on the red line, folks, because the 2 teams that end up below that line at the end of this round will be facing off for elimination to either stay in this competition or they'll be leaving, Ben. So
Paul, I consulted with some middle school-aged kids of a friend of mine, and they told me the right emoji to use is worried face.
Okay, so, all right, cameras on the competitor deck, you're going to just be panning for worried faces. That's what you guys will be looking for.
Right, you might know this as Unicode point 1F61F, but this is worried face.
I hope someone checks him on that fact.
Pretty sure I'm right, actually. All right, so with that, I think we're going to play through the rest of round 1.
Let's see how this first round goes here, Ben.
Craig, roll it. Okay, so a lot of churn early on, but it's the teams are getting sorted here.
Takes a while for those scores to stabilize, but it looks right now like we've got a shootout in the basement here between Dragon Radio, Howmake Radio, and Gator Wings, Ben.
Yeah, Zelenium, Andersons, and Erebus all kind of trying to elbow each other out of the way for first, second, and third.
Yeah, and we've stabilized a bit down at the bottom. It looks like, oh no, now we have Howmake Radio and Gator Wings both below the cut line, Ben.
So we're about halfway through the round. There's still plenty of time for this to change. It's pretty clear that Erebus and Zelenium are solidifying their spots up in the top 3.
Gator Wings is falling back here, guys, but Howmake Radio and Sodium 24 are still really close at that cut line.
Looks like Anderson's just knocked... Oh, there's a lot of shifting happening. Marmot E just knocking Anderson's down from 3rd place.
Okay, things look like they're starting to get entrenched as we pull to the end of this round here, Ben.
And Zelenium just eking out Erebus at the very end for 1st place. Let's see.
Let's do the math.
What is that? 300-ish points? Zelenium just took that round by.
Nice job.
Erebus in 2nd, Marmot E in 3rd.
But of course, Ben, unfortunately, this means we've got Sodium 24 and Gator Wings headed into the dreaded knockout match. Grant, these two teams that are about to go head-to-head, of course, one of them gets to continue on in this competition, and unfortunately the loser will be out. I gotta imagine there's a lot of nerves over on the deck right now.
Yeah, I think everything here is on the line for Gator Wings and Sodium 24. It's kind of a David versus Goliath matchup. You've got Sodium 24, who's the solo new kid on the wireless block with the very advanced AI, versus University of Florida's wireless information networking group with over 20 years of experience. It could go either way.
All right, Grant, thank you. And Ben, I think with that, it's probably time for our first knockout. Should we get things going?
Craig, can you pull up the match? All right, Craig, roll it. Okay, we're off. Now, I should explain right away here, Paul. We see Sodium 24 on one side of a gray ensemble and Gator Wings on the other.
Right. So we've actually taken the top 3 teams from that round. We've anonymized them. You see them here in gray. They're sort of filling out the other 3 spots so that Gator Wings and Sodium 24 can shoot it out head-to-head.
All right, so I just saw points go on the board, Paul. Gator Wings hitting 41.
Yeah, I'm seeing a lot of stability here in the bottom right, Ben, out of Gator Wings as well as out of the 3 placeholder teams, but Sodium 24, unfortunately, is churning and churning and churning, Ben.
So right now there's a lot of space in the spectrum, so there's still unused space.
Okay, Ben, we just moved to stage 2. Point values are now doubled. Lots of time to catch up here, but Sodium 24 is going to have to start to find some stability here that they really seem to be struggling.
Right, Gator Wings about 250 points ahead, but that's still a very closable gap with double points here in stage 2 and triple points in stage 3.
Yeah, a lot of stability again out of the ensemble, Ben. That's exactly what you expect from the top 3 ranking teams. A lot of stability.
Oh, we just saw a burst. Okay.
Sodium 24 appears to be just jumping briefly over the line and then coming right back. So they're going to have to get a lot more stability here in this final stage, Ben, if they're going to beat Gator Wings.
All right, so the spectrum clearly more congested at this point. Stage 3, the most difficult of them, although if you can get points on the board, it's a 3x multiplier. So this Gator Wings is about 500 points ahead.
Yeah, Gator Wings is racking up points, or is racking up stability here in the bottom left, but Sodium 24 just occasionally getting some of those links to close, Ben.
So we're approaching the end of the match here. If Sodium 24 is able to get above that bonus threshold and outscore, then they might be able to catch.
Oh, Ben. And with that, unfortunately, Sodium 24 eliminated from this competition. Malcolm, I want to thank Malcolm Stagg, the solo team member from Sodium 24. And in fact, every competitor up on the deck needs to thank Malcolm. Malcolm made huge contributions to our collaboration language that every radio uses. All right. Really impressive to see Malcolm make it this far. Unfortunately, not able to make it through the knockout in round 1. But with that, round 1 in the books. Grant, over to you.
Absolutely. That concludes round 1, everyone. Now we head into round 2 with only 9 teams. The slate's wiped clean, all scores are reset back to 0, and we enter a new battleground. Get ready for Off the Cuff.
Aid organizations responding to a natural disaster must typically create an ad hoc communications plan, a process that can take weeks. In Off the Cuff, a natural disaster has brought 5 organizations together to provide emergency aid. This scenario tests the ability of SC2 radios to find available spectrum in order to respond during an emergency by self-organizing faster than human planners and optimizing spectrum reuse. The team's radio networks are divided into 3 locations. The north and south locations are far enough apart to enable radios to use the same bands with minimal interference. The small amount of spectrum available requires the radio networks in the north to occupy the same channels with radio networks in the south. Spectrum reuse. Spectrum reuse is a powerful enabler for increasing the capacity of the RF spectrum. SC2's collaborative radios are primed to identify and dynamically take advantage of these opportunities and achieve efficiencies that go beyond 100% spectrum use.
All right, here in round 2, each team had the opportunity to play in 35 matches. And as we just heard in the scenario, what we're looking for is spectrum reuse.
All right, so now to just give the audience an idea of the kind of spectrum reuse we're looking for. So it's pretty dark in the back, I can't see, but you know, it's possible some conversations could be happening over top of us, Ben, even though we're using the same spectrum. But those people are smart enough to keep their voices down. That is exactly what we're looking for in this scenario. We're looking to see these radios use intelligence to figure out when they can reuse the spectrum and when they can't. And we want to see some gain from their ability to find those reuse opportunities.
Right. So in the match that I've picked for us to look at, our competitors are the Andersons, Erebus, Marmot E, Scatter, and Zelenium. Now, Paul, hopefully this doesn't give away too much. We're calling this match Saving Private Scatter.
So Scatter, you've been in this competition for 3 years, and the fact that you haven't gotten a promotion yet is mind-boggling to me.
That's my fault. I apologize.
Let's see if you deserve it after this match is over.
Okay, let's go ahead and move into the match. Greg, can you pull it up? We're going to start with the spectrum on top and our bonus view on the bottom. Paul, we're going to take us until about a minute and a half in. And once things start registering,
there we go.
Actually, things are going pretty well here, right? We saw the ensemble get into bonus pretty quickly. Now, Scatter's sort of floating. Oh, not the right tool. Scatter's sort of floating right around the bonus threshold, occasionally dropping below it, but they are able to recover and get back above it.
They're clearly above that bonus threshold, and the rest of the teams are scoring a lot of points while the whole ensemble's in bonus there, Ben.
Right. Overall, this is really good. Now, if we look at what's actually happening in the spectrum, one of the things I want to highlight is the ensemble is doing a particularly good job of avoiding scatter in the spectrum, right? It's really clear everywhere you can see cyan. You don't really see a lot of other things, and you especially don't see Marmot E.
Yeah, so Ben, we might think that, as we just saw, Scatter was scoring the fewest number of points in that part of the stage, but so maybe the other teams are sort of coming back and making way for Scatter because they're not scoring well. But Scatter was over the bonus line.
Right, they're over
and a number of these AI systems will come back and help out, but only if a team is actually struggling to go over the bonus. So clearly something else at play here, Ben.
Right, so I think at this point we should come back out and get a better understanding of why things are hard for Scatter right now. Craig, can you move us into the spatial view? Okay, so you see Andersons and Marmot E up here in the north zone.
Yep.
We've got Zelenium and Erebus in the middle, and Scatter is in the middle. Right, I'm sorry, Zelenium and Erebus in the south. Scatter is in the middle.
Right, so this is actually the hardest zone because Scatter has to contend with both the interference from the north as well as the interference from the south. They really get it from both sides, and they get the most interference.
Right, so let's take a deeper dive on which teams are actually doing a good job of protecting Scatter. Craig, in the spectrum, let's turn off everyone except Marmot E and Scatter. And I'm going to zoom up here. Okay, right off the bat, this looks pretty good.
This looks great. I mean, it looks like Marmot E has clearly sort of left a swim lane, or many swim lanes maybe, open in the spectrum for Scatter.
Right. Marmot E, doing great. Let's keep going. Let's look at the other north team, the Andersons. So let's turn off everybody except Andersons and Scatter.
So now we go to pink.
Okay, so
still looks pretty good.
It's pretty good. So Anderson's using 6 channels here. 5 of them appear to be pretty well deconflicted, although we can see some perhaps accidental jamming here. Although, if you notice, they do turn it off.
Yeah, eventually I think they figure out that they were interfering with Scatter. They seem to pull out of that channel. So the north zone doing quite well.
Right.
Now why don't we go check out how the teams in the south are doing.
Okay, let's turn off everyone except Zelenium and Scatter. It's not terrible. It's not terrible.
It's pretty good.
You can see some chunks here where Zelenium appears to be making some encroachments, perhaps.
Okay, but still not too bad. Scatter was scoring points.
Right. Not amazing. Not terrible. Let's pull up our last team, Erebus and Scatter.
Okay, so clearly the worst of the 4, but...
Worst being relative here, because this is still pretty good.
Yeah, I mean, right, we're still dynamically moving through spectrum. We've picked a freeze frame. This is kind of like pausing your TV, and it's not particularly great face you make in any one frame. But, so not too bad, but some room to be improved upon, I think, Ben.
Right, but the team that was doing this best was very clearly Marmot E, and they're sitting at the top of the leaderboard.
Look who's at the top of the leaderboard right now, yeah.
Okay, but so just deconflicting with Scatter isn't really the point of the scenario, right? The point of the scenario is spatial reuse.
Exactly.
So we're going to take a deeper look at that. Craig, can you draw me some interference zones around north, middle, and south? So what we're going to do now is draw these interference zones around the north, the center, in the south. And this allows us to look at the spectrum as we would see it from just within that zone.
Yep.
So it's like a very specialized filter that's only possible because of Coliseum. Now, so this is the spectrum as you see it from the north. This is the center. This is the south for what I want to do. We don't care about the middle one. Craig, blow that away, please. Great. OK, so now we've got the spectrum from the north and the spectrum from the south.
All right, Ben, so here's what we're trying to look at, though, right? So we're trying to actually figure out whether teams from the north are sharing from teams with the south. Now, I've spent almost 3 years staring at this tool. So this looks really good to me because I see a lot of matching up between the upper and lower picture here. But Ben, for our audience, why don't we go ahead and combine these together so that they can get a better sense of how spectrum reuse is happening.
All right, Craig, you want to merge those for me?
There we
Okay,
go.
there we go. So let's go ahead and take a look. So what we're looking for are for the teams, everywhere we see teams in the north, blue and pink, did I get that right?
You did not.
I did not, it's red and pink. Everywhere we see red teams in the north, red and pink, we want to also see blue and yellow.
Right, so we want to kind of see this pairing up or this banding where the north teams and the south teams share spectrum with each other. And I see a lot of, wherever I see red, I see yellow or blue. Wherever I see pink, I see yellow or blue. So this is looking great, Ben. This looks like they've really figured it out.
You can they've clearly created gaps in the spectrum for someone else to use that space.
So they're sharing spectrum, but we don't know that it's working. So I think we actually need to ask the question, is there interference here, or is this really sharing, Ben?
Well, this amazing tool has a very helpful button. Craig, will you please push the interference button? Okay, so what we just saw was most everything dim out, right? So the only energy that is highlighted in the spectrum right now is energy that is associated with interference.
Right, this is a case where less is more, right? What we want to see is we're trying to bring out and show where interference is happening. We want to see all of the things that, we want to see the whole spectrum disappear. Now, we've got bits of interference here and there, and we should expect that these radios are adapting and moving through the spectrum autonomously, but there's a lot more here that's working than not, Ben.
That's right. So let's go ahead and come back out and give us our God's Eye spectrum back, Craig, and pull the bonus on the bottom. And we're going to keep playing a little bit. Now, Paul, if you look at what's actually happening in the spectrum, this is a mess.
It's a beautiful, beautiful mess, Ben.
Yeah. There's barely any spectrum that's not being used by at least one team.
Yeah, I mean, it looks mostly all used up. You'd have to really hunt and peck to find some part of the spectrum that wasn't used by at least one team.
And a lot of it looks like it's being used by multiple teams.
Right.
And once again, let's check out Selenium clearly going into Hulk mode here, right, in the middle of this. And
it's working for them. Look how many points they're hulking out to.
132 points per second, and the ensemble is still in bonus.
Yeah, this is great, Ben.
So this is going really, really well. Now, why don't we try to quantify actually how well this is working from a spectrum reuse perspective?
Yeah, I'm pretty sure if you don't show a room full of spectrum policy people and engineers a pie chart at some point, they will storm out the door, Ben.
I hear policymakers love pie charts.
All right, show us the pie chart.
Craig, give us our pie chart. Pie chart. All right, so Paul, check this out. 235% spectrum occupancy.
Yeah, so just to sort of put this in context, Ben, right? These are 5 teams. We're mimicking a response to a humanitarian crisis, to a disaster. Let's say that these 5 teams come from different nations. Today, if we actually had the opportunity to plan spectrum ahead of time, which we don't always, if we did, though, we'd get at most 100% reuse, or 100% use of the spectrum, right? Each team would get a lane in the spectrum, and if they used it all the time, they would be using 100% of the spectrum. But because these teams have actually actively sought out reuse, we're seeing almost 2.5 times more spectrum usage than we'd get today, Ben.
Right, and one of the things I want to point out, and the way to understand this, is you can see sort of 2 shades of coloring here. So Selenium, for example, you see this dark band of blue.
Yep.
That's the only portion, that represents the only portion of the spectrum that Selenium is occupying that's not used by at least one other team. So you can see very clearly that the vast majority of the spectrum that they are using is being shared with at least one other team in the ensemble.
Right, so they're using up 85% of the spectrum, and most of the spectrum that they're using has at least one other team that they share with.
Right, and check out Scatter and Marmot E, for example, as almost 100% of the spectrum that they are occupying is also occupied by at least one other team.
All right, awesome. I'm impressed so far, Ben.
Okay, well, let's keep going. Craig, can you roll us through the rest of stage 1? Perfect.
There we go.
Okay, so Ensemble clearly doing really well here. 4 of the 5 teams scoring in the hundreds of points per second, and you can see the points racking up, right?
Yeah.
Now, in stage 1, the teams are separated, as we saw. Craig, can you go ahead and move us back into the spatial view, and we're going to move into stage 2. In stage 2, things get more difficult, where
There they go. Right, so in stage 1, our teams had to find another team, another radio network to try and go pair up with to get spectrum reuse. Here in stage 2, because we've taken their network and distributed it across this harbor, they can actually share or reuse with themselves. So an interesting new opportunity for these teams in stage 2. Let's see how well they do it, Ben.
Right, so there's the opportunity for both inter-team spectrum reuse and intra-team spectrum reuse.
Yeah, I think we're going to want to stick to more colloquial words, Ben.
Right, my bad. Okay. Craig, let's roll it. Okay, so right off the bat, it's pretty clear this is more difficult.
Yeah, in stage 1, we saw these teams sort of rocket over that bonus line, and here we see a lot of struggling. It looks like maybe Andersons and Zelenium and Erebus are
You can start to
occasionally
see
coming
teams
back.
coming back to try to help each other.
Right, or I'm sorry, scatter.
Yeah, and unfortunately about halfway through this stage here, this is really indicative of the way the rest of this looked. Right, this is clearly more difficult for the ensemble, and they struggle to really get everyone over that bonus threshold.
Right, Ben.
So let's go ahead and pull up the spatial view on the bottom. We're once again going to look at interference zones. Okay, we've got interference zones. Let's move to our spectrum. Great, now we're going to turn off all the teams except Selenium because there's something really cool I want to show everybody.
And it's not a Hulk this time, is it?
It's not a Hulk. There is no Hulk. We are, this is very Bruce Banner. Okay? This is the center, and this is the south. Now, from perhaps the back of the room, you probably can't see in detail what's happening in these, but you'll note that the color pattern looks very similar across these 3 charts.
Yeah, Selenium's doing exactly what we wanted to see here, right? Which is in the north and in the center and in the south, they have the same spectrum footprint, which means that they're taking opportunity to reuse the spectrum with themselves. They've become a good spectrum neighbor and are really leaving lots of opportunity for other teams to use the same spectrum. So this is exactly what we wanted to see in stage 2 of this match. Great job by Selenium here in doing it.
Yep. All right, let's come back out. Craig, pull up our God's Eye spectrum view again. Throw the bonus at the bottom. Bonus at the bottom.
There we go.
Thank you. Roll us forward. All right, now, through the rest of this match, what we see is, unfortunately, the ensemble doesn't really do well. Scatter continues to struggle a little bit. We're going to start to see some of these teams come back to try to help them. But overall, stage 2, clearly not as successful as stage 1, even though we saw teams doing really good things.
Yeah, Ben, but I think we should still foot stomp how impressive what we saw in stage 1 was, right? We saw awesome spectrum reuse, right? We went from where we today could have had at most 100% use of the spectrum to almost 250% use of the spectrum, 2.5 times more. So our first stage was hugely successful, and it was because 2 things. First, our teams recognized that they had to protect scatter. If they didn't protect scatter, they weren't going to be able to get into bonus, and they weren't going to score the rest of those points. But then they realized that they had to pair up in order to get as many wireless applications into that shared spectrum. Ben, this was teams responding to an emergency situation and improvising a spectrum plan on the fly and completely autonomously and doing better than we would do today. Ben, this first stage was great.
Yeah. So that wraps up this match. I'd like to come out into our round leaderboard. Now, once again, there we go. Each team had the opportunity to play in 35 matches in this round.
Yeah, and folks, I begged Ben to let us show you every match like that, but he insisted on the leaderboard as a way to sort of zoom through time here. So,
Paul, if DARPA had taken my suggestion and actually deployed the time-dilating gravity wells you have in the basement, we would have had enough time.
You can't get everything you wish for, Ben, and you know that.
That's a pretty good denial.
All right, so let's go ahead and let's see what happens here in round 2, Ben.
All right, Craig, please roll the round. Okay, once again, we're going to see lots of churn early on, but this is just teams just starting to put points on the board.
Team Gator Wings just hanging out right above the cut line, and we saw them down here once before, Ben.
So we saw Marmot E do really well. in this scenario, and we can see them putting a lot of distance between first place and second place.
Oh, and there goes Gator Wings, hitting their stride, moving to the middle of the pack, but pushing How Make Radio and now Sprite below the cut line with Dragon Radio, Ben.
All right, so we're over halfway through this round. Marmot E clearly solidifying first, but it looks like we're going to have a little bit of a battle for second and third here. Anderson's pulling ahead of third.
Yeah, and okay, so now we've got How Make Radio and Dragon Radio below the cut line, but now it's Sprite below, and now it's How Make Radio below the cut line.
Zelenium.
And now it's Sprite again. Come on, guys, make up your
Erebus
minds.
and Zelenium going back and forth, fighting. Zelenium just eking out Erebus once again. Zelenium taking second, Erebus taking third.
And How Make Radio just clawing ahead of Sprite here. So unfortunately, we've got Sprite and Dragon Radio headed into our next elimination. Grant, what's the mood like over there with the competitors?
Well, guys, we've got 2 new teams on the chopping block for this elimination round, and you can think of this as an Eastern Division face-off. You've got Team Sprite from Northeastern University in Boston, and our Drexel University Dragons from Philadelphia. So who's going to come out on top? Let's find out.
Okay, and with that, it is time for our second knockout, Ben. Let's get this going.
Craig, can you pull it up? And roll it. Okay, I want to point out both Dragon Radio and Sprite are in the north zone together, so one of our top 3 ensemble teams is in the difficult central position.
Right, and right off the gate, right out of the gate, excuse me, Ben, we see a lot of stability from our placeholder teams. We see, however, Sprite looks like they're struggling to get across that bonus line. We see some of the placeholder teams and maybe Dragon Radio coming back to help them, make way for them, Ben.
Yeah, so Dragon Radio and Sprite both scoring right now. Dragon Radio just south of 100 points ahead of Sprite, but we're still in stage 1. Tons of opportunity here to make up that gap.
Yeah, Ben, and we're now into stage 2. Again, point values are doubled. Dragon Radio right back across that line. Sprite flirting with it, and they've swapped positions.
Now, I'm not seeing really any gaps at all in the spectrum ball. It's worth calling out here. We can see Dragon Radio.
There they go.
What we expect from them, which is just sort of shooting right down the middle of the spectrum.
Yeah, it looks like Dragon Radio and Sprite are Clark Kent and Superman. Only one of them can be in the room at the same time here, Ben. And there we go.
They're moving up together, but Dragon Radio is so far able to maintain their point lead over Sprite.
Okay, and now we're into the third stage. Point values triple. Plenty of room to score points here in this third and final stage. And Ben, now it looks like, okay, their Dragon Radio goes, but now they've traded positions. It's actually Sprite that's easily getting above the line and Dragon Radio that's struggling here in this third and final stage, Ben.
Yeah, Dragon Radio not just over 200 points ahead. Still a very closable gap.
There they go.
All right, they're not that far ahead. Spectrum is absolutely crammed, but we're coming to the end of the third stage here. If Sprite can't pull ahead, I think
there. And with that, unfortunately, Sprite eliminated in round 2 of our competition. Sprite, you guys had a great, unique approach. I loved the combination of mathematical optimization with bits of AI. You guys had a very altruistic approach, but unfortunately, not able to be successful here today. Thank you, Team Sprite. Okay, and with that, we're now on to round 3. Grant, get us going into round 3.
Okay, we're heading into round 3 with 8 teams remaining. Once again, all scores are reset to 0, clean slate. It's time for us to check out Wildfire.
Military and first responders provide some of the most stressing spectrum usage scenarios due to the critical nature of high-priority communication tasks. Today, emergency operations require all non-essential traffic to be cleared from the airwaves. The Wildfire scenario tests how SC2 radios can collaborate to preserve high-priority traffic while maintaining non-critical communications. In the Wildfire scenario, 5 containment teams have converged on a fire zone under short notice. In this scenario, each team is composed of on-the-ground crew members, an aerostat, and air tanker firefighting planes. The air tanker missions are highest priority, and the ensemble needs to collaborate to safeguard all communications with all air tankers. In each stage, the air tankers communicate using high-priority command and control and video feeds to the ground crews. Teams whose SC2 radios solve this long-standing communications challenge faced by military and first responders in emergency situations will be awarded maximum points.
right.
Okay, in this round, each team has the opportunity to play in 25 matches. That number is going to continue to go down as the number of teams that we have goes down.
Right, fewer teams, fewer combinations.
That makes sense combinatorially. All right, what we're looking for in this match is prioritization. So, in the match that I've picked for us to look at, we're going to see the Andersons, Howmake Radio, Marmot, E, Scatter, and Zillennium. Now, Paul, we're calling this match Ground Control to Marmot E.
I love it. I saw that Marmot E brought a small Marmot with them. If you could maybe get that with some Ziggy Stardust flair throughout the rest of the match, that would be good. I'd appreciate that.
Did you just come up with that? David Bowie would be proud. That's pretty good.
He would.
All right, let's go ahead and jump into the match. Greg, please pull it up. We're going to start out spatial view up top, our application view at the bottom. We're moving quick. I'm getting us to a certain point. Before we get there, there's something I want to highlight, which is the stars. So this is the application view that we talked about before. The stars indicate those priority flows that we just heard about in the intro video. You can see them here on the chiclets. You can see them here spatially, and you can see them here on the leaderboard.
So never fear, audience. There are stars everywhere. You shouldn't be able to miss them wherever you look.
When in doubt, you just add more stars.
Add more stars.
Okay, now, the reason that we've stopped here is look at what Marmot E has done. They've closed that big link.
Yeah, and so it's worth noting here, right, that in most of this competition, Ben, a video flow is worth 10 points every second that you have it closed. In this scenario, to emphasize how high priority the video flows here are from our air tankers, we've made it worth 200 points. So you can see that because it's a bigger box here. Huge opportunity for any of the teams that are able to close those video flows to score high points in this match here, Ben. And we already see that maybe Marmot E has some tricks up their sleeve here to rack up a lot of points, Ben.
Now, unfortunately, Marmot E is not going to be able to hold it here. Now, Craig, can you go ahead and start playing the match? We're going to play it through at 20x. You'll see they drop it real quick. And we're going to move through
there we go.
To a point in stage 4. But moving through stage 2 and moving through stage 3, we'll note that no team is able to close those big links.
But we do still see Marmot E really trying to get those links closed, and occasionally we'll see Howmake Radio do the same. But the other teams really don't even seem to be interested in the 200 points that we've put out there for them, Ben.
Yeah. Now we're gonna play this forward and pause right here, right where Marmot E has once again closed that big 200 point
Nice job,
link,
guys.
right? Now, if we look at what's happening spatially, we saw that air tanker formation fly over Marmot E's own ground crew, then cross Zillennium's ground crew, and this is where they closed it.
And then things magically started working, Ben?
Yeah, you could say that.
Okay, foreshadowing, I see.
Okay. Now, let's go ahead and continue. Now, we're going to see Marmot E lose it briefly, but then they get it back. Here we go. So they're going to lose it, they get it back, and then they hold it for the remainder of the match. So this Marmot E closing and holding that link, no other team was able to hold that link in any match in this entire round.
For as long as they did it.
For as long as they did it.
Wow. So, I mean, this is incredibly impressive. Great job, guys. Because for this to happen today, every air tanker that is in this scenario would need its own dedicated spectrum.
Including all of these over here.
Exactly. Not just the 5 that are flying in any one pass, the other 10 sitting and waiting off to the side. And if we allocated all of the spectrum for the 15 air tankers, the 35 ground crew members, the firefighters, would have nothing left to actually use, Ben. So this is incredibly impressive that they're able to navigate and get that high priority traffic delivered.
So we saw them close that link, close that priority link in stages 1 and 4. So I want to go back and take a look at how they did that. Craig, can you pull us back into stage 1 where Marmot E was able to close that link the first time? Okay, so what we've done here is we're looking at the spectrum only from the view of Marmot E's air tanker.
Okay, so this is different than all the other spectrum views we've had because it actually is from the perspective of one node.
Right. So you can see this air tanker right flying over the ground crews, and once again we're looking at this from the perspective of the interference zone as we saw it last time. So this is the view of the spectrum as seen from Marmot E's aircraft. So let's look at what's happening. So right off the bat, right, you can see how the spectrum changes as they fly over the ground crews. So here, actually, in this area, they're flying over their own ground crew. Then they cross over Selenium's ground crew, and you can see Anderson's come into view, and you can see Scatter come into view, and then they fly over How Make Radio. Now, look at how Marmot E's handling their spectrum usage.
Okay.
You can see they're using 2 channels at a time, right? And you can also see that the moving channels, right? So here, for example, they're using these 2 channels, and then here they're using these 2 channels, and then here they're using these 2 channels, right? Now look at how many times they do this as they fly over the ground crews. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that they've autonomously maneuvered through the spectrum 10 different times in order to maintain these links.
And Ben, it makes a lot of sense because when you think about it, at first you might think, well, there should be maybe 5 moves, 1 for each team that you fly over. But in between flying over each team, you're actually experiencing interference from 2 teams at once. And so it makes sense that they're sort of navigating the spectrum 10 times here in this stage, Ben.
Right. But as we saw, they weren't able to hold it here. So let's look at what happened in stage 4.
Where they held it for the whole time.
Right. Craig, can you take us forward into stage 4? Okay, same deal, right? So this is the view only from Marmot E's air tanker. And as we see them fly over the ground crews in formation, we're going to see the different teams come into view in the spectrum.
Right.
Right? So they're now coming over Anderson's, and now they're flying over Scatter, and now they're flying over How Make Radio. You can see them all coming into view. So I'm just going to go ahead and zoom down here. Okay.
So Ben, the first time we watched this, right, you paused it right after they got over Selenium. And that's when things started to seem to work. So maybe it's clear that there was a challenge here with Team Selenium.
So this is Selenium, right here. So Craig, can you please turn on our interference filter?
So I think that probably answers the question for
basically,
everybody, Ben.
all of the energy in the spectrum went away, which means all of the other energy is working except for all of the energy when they're on top of Selenium.
Right. The only fuzzy spot we're seeing is the areas where Selenium was actually trying to share spectrum with Marmot E here in this case, Ben.
Right, and once they are able to get clear of that, that's when they close the link and then they hold it through the remainder of the match.
Okay, Ben. So in this match, though, we saw Marmot E not once, not twice, but 3 times able to close that high priority link. They've absolutely earned their point total, sitting well atop the board here, and they were able to do this not just effectively but efficiently. We should see how this plays out now, Ben, as they go throughout the rest of this round of play.
All right. Craig, I think we're done here. Can you pull us out to our round leaderboard? All right. So we saw Marmot E do that well. Let's see if they can continue it. Once again, each team has the opportunity to play in 25 matches in this round.
All right. Let's see how it goes, Ben.
Craig, roll it. All right. And we're off. We'll see this early churn and then see how things stabilize.
All right, we've got Gator Wings and Dragon Radio below the cut line right now, but Gator Wings picking up speed, probably going to displace How Make Radio right there.
Now, as expected, Marmot E putting a huge gap between them and second place.
Yeah, I mean, I think we know exactly why that bar is so big for Marmot E there. But down in the bottom, Ben, we have How Make Radio and Dragon Radio with a sizable gap between them and the next highest team.
Ooh, Erebus just hitting that elimination line and then now climbing their way back up.
Okay, so Ben, we're getting close to the end of this round. We're seeing a lot of churn in the middle, but a lot of stability here in these bottom 2 positions. Looks like How Make Radio and Dragon Radio.
Done.
Wow.
Marmot E taking first place with a 200,000 point lead.
It turns out that those extra priority flows were really worth a lot of extra points.
Yeah, Selenium taking second and Gator Wings taking third.
Okay, Ben, now we should have How Make Radio and Dragon Radio headed into the elimination. But Ben, as we went through all of these matches, you actually found something that we need to share with the audience.
Yeah, so unfortunately, while I was diving into all of these, I found some buggy behavior, and so I raised it to Paul.
Yeah, so a key component of this competition, because this is a collaborative competition, your radio has to work throughout the entirety of a match. If your radio crashes, let's say 1 minute in, all of a sudden you've taken away the ability for any other team to score points. So we call this the defective radio rule. And unfortunately, if we find this behavior, we have to remove that team from competition, Ben.
Right, so there's actually a match that pretty easily demonstrates this. Craig, can you pull up match 150? Now we're going to play through this match at highly accelerated 20x speed. Now, Paul, here in stages 1 and 2, everything looks normal, right? You see the entire ensemble in the spectrum, and you see every team...
A lot of point jockeying going back and forth as
moving
we
around.
see.
When we move into stage 3, unfortunately...
this is where the behavior happens.
Right. From here forward, we never see Dragon Radio leave the start line.
Right, and they're stuck down here scoring 0 points. And we see all the other teams, and some of them even adapting to try and help Dragon Radio, using up a lot of spectrum. But
they're still doing things.
Just nothing happening. No ability to score points here, Ben.
Yeah, and...
Wow, so I want to stress that, you know, we should actually, we saw that in very fast time. We should look at this just in chart form here. If we could pull up the chart. This is the score from Dragon Radio in that match. We see that they scored in stage 1. We see that they scored in stage 2, however, flatlining in stages 3 and 4. I want to stress with the audience here that this wasn't the only time we saw this behavior. Unfortunately, Dragon Radio, in over 50% of the matches you played in this round, we saw this type of behavior. And because of that, unfortunately, we had to invoke the defective radio rule. And unfortunately, we have to eliminate Dragon Radio from the competition. So I want to thank Team Dragon Radio. Excellent job getting to this point, guys. Now, Grant, with that, we're done our first 3 of 5 rounds here in the elimination.
That's right. We now head into round 4 with 7 teams remaining. These 7 teams will now face a new challenge. It's called Slice of Life.
Everyone has felt the frustration of using slow wireless at a coffee shop or airport during peak hours. Today, with static spectrum allocations, networks are unable to handle surge demands beyond their capacity. The slice of life scenario demonstrates how SC2 collaborative radios can adapt to surges in demand by dynamically reallocating spectrum. The scenario is situated in an outdoor shopping mall, where each team's radio network mimics a wireless hotspot. Each stage of a match represents a period of the day where one store has heavier traffic demand than the others. For instance, the red team at the coffee shop experiences heavy traffic in the morning during stage 1 and requires the most spectrum resources, while later at lunchtime in stage 3, the blue team at the deli will see a surge in their traffic and will in turn take the largest share of spectrum. In contrast to today's static spectrum allocations, SC2 radios should be able to proportionally allocate spectrum to the network that needs it most at any given moment. The SC2 radio networks that are best able to collaborate and adapt quickly to meet surging traffic demands in congested spectrum will score the most points.
Okay, each team played in 15 matches in this round, and as we just heard, what we're looking for are teams who are able to handle dynamic surges in demand. So, in the match that I've picked for us to look at, our competitors are Erebus, Gatorwings, Marmot E, Scatter, and Zelenium. Now, Paul, calling this match King of the Hill.
Because everyone over here is a propane fan, obviously.
Definitely.
Got
That is definitely the reason. Now, before we get started, as we saw in the video, the teams are going to be taking turns handling surges. So this means one at a time, each team will have the opportunity to score the lion's share of the points. Now, we call this opportunity their lead dog stage. So we're going to take a look at this one stage at a time.
Okay.
Craig, can you pull up the match for us? Now, here in stage 1, Erebus is in the lead dog position. So they have the opportunity to score more points than anybody else.
Right.
And you can see right off the bat, the ensemble moves into bonus, they stay in bonus, and they're doing really well.
Yeah, and we see Erebus up in the top left there using somewhere in the order of 30–40% spectrum of the total spectrum, Ben.
Right, so we've paused here at the end of stage 1. Now, in the lead dog position, there's 237 total possible points per second. You'd be able to see it here if Erebus's 107 points per second wasn't obfuscating it, yeah. But so Erebus is scoring about half of the possible points in their lead dog round.
Okay, not bad.
Right, and they did it very efficiently too. If you looked at their spectrum usage.
Yeah, they're only using 30–40% of the total spectrum to carry this traffic.
Right, and all reused too. So doing great. Let's move on to the second stage. In the second stage, it is Scatter's turn. in the lead dog position. They're currently at the bottom,
Okay,
but
so they have the opportunity to climb to the top now, Ben.
let's see how far they'll go. Craig, please roll stage 2. Okay.
There we go.
So right off the bat, we see super impressive bandwidth reuse numbers here, Paul.
Yeah.
And I want to
Spectrum occupancy is very high in this particular stage.
we're going to cross 300% here, and then we're going to pause it actually, because we hit
Wow.
almost 340% spectrum occupancy.
Wow, that is really impressive, Ben. But what's interesting to me, actually, is that scatter is using up a lot of spectrum, but so is Selenium and Gator Wings.
Right, scatter's in the lead position, so we expect high numbers like 82%. Now, and it looks like they're almost at 100% of that being reused. But yeah, Selenium at 98%, and Gator Wings also eating 88% of the spectrum.
Maybe Gator Wings has like a Gator mode to go with Selenium's Hulk mode.
Now, and Scatter clearly used that opportunity, right, to climb from the bottom up to second place.
But not able to actually unseat Erebus, who's still at the top of the leaderboard here in this match, Ben.
Right. Now, our next lead dog turn goes to Marmot E. Now, once again, at the bottom of the leaderboard. We'll see what they're able to do with the opportunity.
Climb on up.
Craig, let's roll it. Okay. Now, Marmot E uses this. They occasionally push forward into this 130 point per second range.
Really sort of hitting the same amount of points all the time here, Ben.
Yeah, and so if you look closer at what they're doing, it actually looks like they are trying to maintain the quality of the links that they establish, rather than putting them at risk by just trying to cram more stuff in.
Okay, so they could keep trying to get a bunch of half-serviced applications into the spectrum, but rather than do that, they've sort of wisely figured out which applications they can service and are sort of holding back on the others.
Right, and this worked for them because they just
rocketed to the top.
They just unseated Erebus and Scatter, have taken first place.
But I actually think there's something really interesting happening if we look at second place on the leaderboard here, Ben.
Right, so we see Gator Wings in second place here, which is surprising because Gator Wings has not yet had the lead dog turn.
But if you look at the bottom and you see the scores, right now Gator Wings is scoring all of the possible points that they can score in this stage. So I think that, Ben, that's really how they've climbed up the leaderboard to where they're at this point. I think it's going to be impressive when they take that lead dog position.
Yeah, well, now it's Gator Wings' turn in the lead dog position.
Okay.
Lead Gator position. I should have had another icon made.
You should have had another icon made.
My apologies, Gator Wings. Okay, with that, let's roll this stage. Okay, so in the beginning here, we're going to see Gator Wings kind of probe the spectrum, try to figure out what they can do, what the capacities of their links are.
Oh, wow, they're up to 149 of the 200 points, Ben.
Right. They
167.
They hit 167 points per second, outscoring what anyone else has been able to do so far. And interestingly, they do this sitting most of the time at about 60% spectrum reuse.
Yeah, they were actually using more
60%
spectrum back in stage 2 than they're using right now as the lead dog. So
yeah.
They're being incredibly efficient about how they rack up that 167 points, Ben.
Right, and in the process, they have now taken first place, unseating everyone else who has had a lead dog turn so far.
Selenium is the only team left that hasn't had a lead dog chance.
Right, so the question is, will Selenium be able to unseat Marmot E and Gator Wings?
Ooh, okay, let's see.
Craig, let's roll the final stage.
There they go.
And they're off. Now,
they're off to a kind of a slow start here, Team Selenium.
Now, Paul, they're going to be, Selenium here is going to hit 170, there it is.
That's the most points we've seen.
They hit more points than anybody else, but this stage is going to end. Selenium taking second place from Marmot E, but not able to unseat Gator Wings.
Wow, that is really impressive from Gator Wings. Unfortunately, I think Selenium maybe just not jumping up fast enough there to get enough points to unseat the Gator Wings.
So I assume that it's now clear that we call this King of the Hill because, not because Gator Wings likes propane, but because they are indeed King of the Hill.
They might still like propane.
Okay, my apologies. You guys might like propane. Yeah. So this is the first, yeah, a round of applause, well deserved. So this is the first match that we've looked at where the ensemble has been in bonus for almost the entirety of the match.
Yeah, Ben, and I actually want to take us back to stage 2. We hit that lovely pause point. We had 340% use of the spectrum, so 3.5x. Right, that means this is a 20 megahertz scenario, so that means we were taking the equivalent of what was 70 megahertz worth of spectrum and cramming it down into 20 megahertz. I would like to dig in a little bit and see what happened behind the scenes to make that happen, Ben.
Sure. So Craig, pull us back to where we had those unbelievable spectrum reuse numbers, and now we're going to pan
There
Perfect.
we go.
Okay, so this looks nuts, right? This is absolutely jam-packed.
Unlike before, I literally can't even find a pixel that's not being used by one team, Ben.
Right. Now, the question is just not can you fill the spectrum with energy, but can you do it while collaborating?
Right.
So, Craig, can you please turn on our collaboration filter?
Okay, so I think to most of the audience, it probably appeared like you just changed all the colors in the spectrum, because not a whole lot changed, right? So
everything that you're seeing is energy associated with collaboration, as in more than one team is occupying that particular point in time and frequency and space,
right.
And it's working.
So we just sort of brought up all of the points in the spectrum where two teams are using it and both successfully scoring points there. Hard to see it from this perspective. Again, maybe less is more. Why don't we flip it and look at the other direction?
All right, Craig, let's invert that and turn on our interference filter. Okay, so not perfect, but a lot of it fell away.
Right, so again, we've got autonomous radios navigating the spectrum without a plan. They're going to make mistakes, but we want to see them learn from their mistakes. A lot more, again, here working than not, Ben. Most of the spectrum fell away. This is incredibly exciting to see bandwidth utilization numbers this high while teams are still scoring points. I want to see how the rest of round four plays out here, Ben.
Okay, well, let's come out. Craig, pull up the round leaderboard for us. Okay, we are down to, we got 1, 2, 3, 4, 5, 6, 7 teams.
Okay.
The teams had the opportunity to play in 15 matches in this round. So getting shorter and shorter.
Let's see how it goes.
Craig, let's roll the rest of round 4. All right.
We're off to a more lethargic start here, Ben. But
Yep.
we've got Scatter and How Make Radio both below the cut line right now.
Okay, with Gator Wings clearly establishing themselves at first. And more second, Marmot E making a push for second. Airbus same, trying to make a push for third.
Scatter and Andersons are duking it out over which one of them will be going to the dreaded elimination.
Whoa, we got just 4 sets of matches left here.
Andersons is now back in the basement here, Ben, and they're pulling ahead of Scatter, I think. Or Scatter's pulling ahead of them.
Just ended. Whew. We've got Gator Wings in first, Zillennium in second, and Marmot E in third.
Wow, okay, but unfortunately, we have Andersons and How Make Radio ready to head into our elimination match. Grant, these are two really different teams that we have here in this matchup.
Yeah, this is shaping up to be a battle between dark horse competitors, both small teams. Andersons, who placed 11th in this year's tournament, and How Make Radio, a team of radio hackers who joined the competition a year after everyone else and clawed their way to the top to be here tonight. Both are looking for a spot in the final round. Who will hang in there? It's time to find out.
Okay, only one chance for one of our dark horses here to make it into this next round, Ben. Let's get the knockout underway.
Craig, can you pull it up? And roll it. Okay. We're off. We'll take a few seconds here for them to figure out. And there we go. They've come into the spectrum. And right away, we see Anderson's using quite a number of channels.
Right, but I think cutting a pretty clear path for How Make Radio in the spectrum. Anderson's steadily outscoring How Make Radio here, Ben.
It looks like the scores are tied. We've got both of them sitting at 130 right now.
Yeah, now the placeholder teams in gray are all very stable, holding all their applications, so no challenges there. Anderson's doing great. How Make Radio just not getting off the start line, Ben, but we're in stage 2. Point values are doubled.
Yep, they're currently tied. And the spectrum is way more crowded, but it looks like the Anderson's clearly using more spectrum than How Make Radio right now.
Yeah, okay, there we go. Now we're scoring points, Ben. It looks like,
All right, so Anderson's used that opportunity to pull ahead.
Yeah, they were scoring about 20 points per second more than How Make Radio was, Ben, in that brief period.
So they're about 250 points ahead, still close.
Now How Make Radio outscoring Anderson's here, Ben.
All right, they used that opportunity to close that gap.
Okay, the scores are really tight now as we head here into stage 3.
There's a triple point multiplier, so they can still catch them easily.
This is anyone's game still at this point here if How Make Radio can come back in and start to score some points.
So we're about halfway through the last stage here.
Oh, Ben, and here we go. It's
We're making
on.
a break for it. Anderson's
almost
up.
a 2-1 score ahead
If they
of
hit the
How Make
top,
Radio,
the match
though.
ends and they win.
Ben,
they might hit it.
and-
They stopped just before.
Oh, Ben, and with just a couple seconds left here, I don't know if How Make Radio is going to be able to recover. And unfortunately, How Make Radio, great showing here today. You guys have come a huge way, starting the competition half the time that the rest of the teams had. It's been a pleasure, guys. Thank you so much. Let's hear it for How Make Radio. Okay, and with that, there is only one round of play left here in the elimination, Grant.
All right. We move into round 5 with 6 teams. And the scenario for this round might make our competitors feel a little claustrophobic. Get ready for Trash Compactor.
Do you ever get the feeling like the walls are closing in? The radios of the future will need to successfully coexist in increasingly congested environments. In the Trash Compactor scenario, SC2 radios are forced into a smaller and smaller spectrum space, while being asked to deliver consistent levels of service. For each stage of the scenario, the bandwidth is cut in half from 20 megahertz to 10 megahertz to 5 megahertz, while at the same time, the amount of traffic in each stage is kept more or less constant. As the walls close in, the point values increase, giving the SC2 radios the opportunity to cash in on their ability to operate in highly congested environments. Radios that can persevere will score the most points.
Okay, there's 6 teams left.
Only 6 of you guys left. The competitor deck is getting emptier.
Each team had the opportunity to play in 10 matches in this round. Now we're getting towards the end of the elimination round, so things are getting more difficult. And as we just heard, what we're looking for here are teams who can perform well in highly congested environments. So their competitors in the match that I've chosen to look at are the Andersons, Erebus, Gatorwings, Marmot E, and Zelenium. And Paul, we're calling this match, It's Just a Flesh Wound.
It's just a flesh wound. Your bloody arm is off.
That's pretty good too.
That's as good as the delivery gets, folks.
Let's move into the match. Craig, can you pull it up? We're going to start with our spectrum view on top, bonus view on the bottom. Now, Paul, we've introduced a new piece of information to our visualization tool, arguably one of the most important pieces of collaborative information. And as soon as the teams start using it...
There we go. Now we start to see it.
We'll be able to see it. Now, you can see these point bubbles here appearing on the team's bonus line. So that one disappeared right as I tried to circle it.
Yeah,
now,
Ben, so I think we need to explain to the audience how this all works because we keep adding more and more icons onto this tool, and I think they're all iconed out at this point. So this is actually a really important piece of collaborative information that these teams share with each other. Up to this point, collaboration that we've seen has been forecast, right? What spectrum you're going to use in the future. But now we're actually seeing the teams tell each other how well they're doing in the spectrum. And in this game, that translates to how well they're scoring.
Right. So, for example, Anderson's is currently scoring 3 points and also telling everybody else we're scoring 3 points. Whereas Erebus, for example, is saying we're scoring 9 points, but actually back here. Now, that doesn't necessarily mean that Erebus is doing the wrong thing. It might be that they're, for example, forecasting, they anticipate hitting 9 points.
They might know they're going to be there in just a second.
Right. So you can't necessarily read this as inaccurate information or misinformation. But for purposes of what we're going to look at here, it's important to understand this as sort of a concept of error bars. So, for example, right where we've stopped right now, there's an error bar with Zelenium, who is scoring 0 but reporting 5. So, Paul, what happens when Zelenium gets angry?
I've heard that you wouldn't like it when Zelenium gets angry, Ben.
Yeah. Let's go ahead and continue, Craig. Zelenium's currently at 0. Zelenium gets angry.
Okay, and here they go.
And we're going to see Zelenium, Bruce Banner goes away, and out comes Hulk. And it works for them, right? You see them come up.
They were able to go from 0, and they're back up flirting with the bonus line here, Ben.
Right, but look at what happened. Anderson's got Hulk smashed in the process.
Yeah, that's
right.
That is unfortunate for Team Anderson's here.
Yeah, and there's a lot of sort of error bars right, in what we're seeing, right? With, for example, Airbus reporting at threshold but being below it. Zelenium reporting at threshold but being below it. Anderson's reporting near threshold but being down here at 0.
Right, okay, so for our non-Python fans here, Anderson's is mortally wounded but saying everything is just fine.
Right. So right, they're saying it's just a flesh wound, but literally missing an arm.
Right.
But the question is, why would Zelenium change their behavior?
Yeah.
Right? They've Hulk smashed Andersons and knocked them down to 0, but as far as they know, the Andersons are actually pretty close to the bonus threshold.
Yeah, Ben, we know, and we've already seen in this competition, we've seen Zelenium come back and try and help out that weaker performing team to make sure the spectrum is fairly shared. But in this case, Anderson's is right in the neighborhood of the ensemble line there, Ben, and so they've got no reason to come back at all. As far as they're concerned, they're in Hulk mode and everything's working great.
Right. Now, you might ask, okay, I'm sort of giving Zelenium a hard time here for Hulk smashing Andersons. How do I actually know that it's them? We can do this by just looking at Zelenium and Andersons. Craig, can you move to my other view here in the spectrum? And what we're going to see, Paul, is everywhere the Andersons is, since they are using substantially less spectrum than Zelenium, we also see Zelenium. Right. They're clearly right on top of each other pretty much everywhere Anderson's is trying to use.
Yeah, so I think it's obvious that Anderson's currently scoring 0 because Zelenium is near the bonus line.
Right. Now, Craig, can you please continue the match? So I actually think what happens here is that the Andersons has lost command and control of their network. Because you saw them just report 7 and it disappeared, and now they don't report anything.
Right. So, the audience may have missed that, but we saw that little 7 bubble disappear from Anderson's. This means right now they're not telling the other teams anything. So these other 4 radio networks have no idea how well Anderson's is doing. So they've got very little to react to right now and probably are going to react just to that last report that they heard.
Right, which was pretty much at bonus threshold.
Yep.
So, Craig, let's continue the match, and we're going to move into stage 2 here. And we know the Andersons knows how to do this, right? They've made it this far. So this isn't like a thing that they don't know how to do. It's just that something has happened within the network. Now, this is a very difficult scenario, right? We just lost a substantial chunk of spectrum, narrowing them down.
Right, yeah, we just cut the spectrum in half, so a lot more to, a lot of difficulties here, Ben, but still not seeing a lot of reporting here from Anderson's.
Right, everyone else is saying, hey, I'm at threshold or better, but we're not hearing from the Andersons. And the last time we did hear from Anderson's, it was somewhere in the vicinity.
Right.
Okay, so Craig, let's go ahead and continue. So at this point, it looks like Anderson starts reporting 4.
Okay, there they go.
They report it several times. And when they do that, that's the first time they're able...
Now look, Zelenium has come back,
right, and Airbus comes
back.
So Anderson's manages to get a flag up and say, hey, we're actually not doing that well, we need help. And we saw other teams react to that.
But I think it's probably too little too late in this particular stage of this match, Ben. So we should see how it plays out in the harvest.
Yeah, so Craig, go ahead and continue. So we're moving into stage 3 here.
We're going to once again cut the bandwidth of the scenario in half. So
right.
Even more challenging.
And unfortunately, I just don't think the Andersons are able to recover the command and control of their network. You see them start reporting 12.
Yep.
Right? But it doesn't actually reflect how well the network's actually doing. So what we've wound up here with, I think due to the complexity and difficulty of this scenario, really is that Andersons haven't called for help. No one knows they need help. And so no one's reacting to it. And they end up totally on their own.
Yeah, and I think this is actually a really interesting way to highlight collaboration, but sort of from the negative position here, right? Because the collaborative information they were sharing had errors, there was misinformation, it was wrong, the teams weren't reacting the way that maybe we would expect them to. And so we can see how important the collaborative information is to these dynamic radio systems because they're not shuffling spectrum, coming back, and helping Team Anderson's out.
Right. It's the negative proof of how important this thing is.
Absolutely.
So that wraps up this match.
All right.
Craig, let's pull us out. Okay. We've got 6 teams left. Only 5 will make it through. Ready?
I'm ready.
Craig, roll round 5.
All right, teams.
Only 10 sets of matches here.
We're moving more slowly than we have in previous rounds.
Very clear that this scenario is very difficult. We don't see a lot of points getting put on the board.
So it looks like so far we've got Gator Wings and Scatter again below the cut line, Ben.
And we're going to end this Woo!
Whoa, with a
Right
little
at the
surge at
very
the
end.
end,
Now-
but not enough for Gator Wings to pull out from below the cut line.
Look, check out the difference in points in the top three, Paul. 276 in first, 275 in second, and 272 in third.
Yep.
Very, very close there.
But unfortunately, we've got our final knockout match teed up, and we have Team Scatter and we have Team Gator Wings. Grant, we've got a tremendous amount on the line here for these two teams. One makes the final five. The other, unfortunately, packs their bags and heads into the audience. Grant, how are the teams feeling over there?
That is absolutely right. Tension is very high here. As you said, only one of these two teams is going to the final round. This is the second time on the chopping block for Team Gator Wings, and Team Scatter have traveled here from all over the world to be here tonight. Who will come out on top? Will Gator Wings skate through again, or will Scatter take them down? Time to find out.
Okay, our very last knockout match here in the elimination round. Ben, I say we get this going.
Craig, pull it up. And roll it. All right, so we're off. We see
And there we
down
go.
alleys spatially. Spectrum already very crowded in stage one.
And Ben, we see Scatter struggling to score points right off the bat here. Some of the other teams, even the placeholder teams, it looks like coming back to try and help them out. I'm actually having trouble, Ben, seeing Scatter in the spectrum.
I see, we just moved to stage two, it narrowed. I see a lot of orange. I also am having trouble seeing cyan. Hey, Craig, can you actually just show us? Perfect.
There we go. And so, again, I think we're seeing the other teams come back and try and help out Team Scatter here.
Well, if you look at it in the spectrum, it actually looks like Scatter is maybe just doing like command and control updates or something. There's not a lot of heavy usage.
It looks like they're not able to find an area of the spectrum to use, and so they're just beaconing there, Ben. And
so we've ended with Scatter
that,
at 10 and Gator Wings at 10.
So we've run out of time in this match, and unfortunately, that means we have to go to our tiebreaker. Now, in the case of our tiebreaker, the winning team is the team who exceeded the bonus threshold the most. Okay, so with no further ado, let's see the bonus times for each of these two teams. Ooh, and there we have it. Team Gator Wings, 2 minutes and 8 seconds of bonus time. Team Scatter not able to get over the bonus line in that match. Unfortunately, Team Scatter, this means that this is the end of the competition for you guys. Thank you so much to our biggest geographically dispersed team. You guys have done a great job. All right, Grant, with that, I think we're ready for the final round. We've got the final five set. Let's go.
Okay, this is it. The final round of the Spectrum Collaboration Challenge. Now remember, this round is happening live from the Coliseum here at Mobile World Congress. Up to this point in the evening, we've known the outcomes because Coliseum has played hundreds of matches for the preliminary rounds. Paul and Ben have had weeks to analyze the data and spotlight the best and most interesting moments. But from this point forward, we genuinely have no idea what will happen next. We're going to all experience these matches live together. We're down to our final 5 teams: Andersons, Erebus, Gator Wings, Marmot E, and Xylinium. In this round, we'll play 4 matches. At the end of each match, teams will be awarded prize points based on how they placed. These points are then summed across all 4 matches to determine our prize winners. And now, we're ready for match 1.
All right, and with that, for our first match, we're going to move the finalists back to the slice of life scenario. This time, we're going to make it a little more challenging for them. Now, not only do the teams have to share the spectrum and handle surges, they now have to contend with a legacy radio system, one that's not smart and doesn't adapt. For the teams to successfully earn points here, they'll need to learn on the fly how to manage their aggregate interference to this incumbent. For example, think of a satellite receiver.
And we'll be able to see the impact of that in the visualization tool. So looking at the spectrum here, you can see half of it has this gray background. That indicates the portion of the spectrum where this passive incumbent, such as a satellite receiving station, for example, is operating. So the teams have two choices. They can attempt to operate within that band, which is more difficult, and I'll dive into why in just a second, or they can duke it out in the area where there is no passive incumbent. Now, if they choose to operate within the shared band with a passive incumbent, then they have to protect it. The passive incumbent has a power threshold. If the ensemble breaks that threshold, they go into a penalty mode where that threshold drops and things get difficult. They have to remain below it before that will reset. So, with that, I think it's time we run the match.
All right, Ben, can they protect a passive incumbent? Let's see how these final 5 do, Ben.
Craig, can you pull it up? Let's roll it.
All right, Ben, now as we start off, we should say there's a 5,000-point finish line here. These teams, the first team to that 5,000-point finish line will stop the clock and will win the first place points for this match, Ben.
Right, now we just saw them break that incumbent threshold briefly, but they've dropped back below it, and they're holding below. Now, not a lot of points going on the board right now, Paul. The whole ensemble is walking up 1 point at a time.
Yeah, it looks, Ben, to me like they're trying to slowly learn what that passive incumbent can tolerate and what it can't. We see they've broken its threshold again, but they've all dropped down in power. And now they're raising that power back up that the threshold comes back up. So we're seeing them start to adapt and figure out when or how they do and do not interfere with this incumbent Ben.
Now, hey, Craig, can you actually show us Erebus? So they just violated substantially. Can you show us Erebus? Okay, so that's it. So Erebus is putting about half of their energy over the passive incumbent. And with the exception of this spike here, Paul, it actually looks like they're doing a pretty good job of staying below it.
Ben,
can you pull us back out, Craig?
There we go. So far, we're partway through the first stage here. We've seen 4 of the 5 teams really jumping into the spectrum. Anderson's is sitting back. I don't know if they're waiting for their turn to go before they jump into the spectrum, but we've seen all 4 of these other teams able to really nimbly adapt their power levels to what that incumbent can and can't tolerate, Ben.
Now, I see Gator Wings actually trying to put most of their energy in that band where there is no incumbent. Craig, can you real quickly just show us Gator Wings before it scrolls off the screen? Yeah, so we saw that big burst there. Oh, well, now that I've said that, I see them up top, too.
All right,
okay,
Ben,
Craig,
so
take us back out.
Ben, we're now into stage 2. Again, just like our previous rounds, point values are doubled here in stage 2. We've seen little scoring so far, but we've seen these teams adapt to the passive incumbent. We've now got 4 of the 5 teams with stable delivery of wireless applications. Still waiting for Anderson's to show up here in this match, Ben.
So the entire ensemble.
Oh, here we go.
15 points.
I'm seeing some Tetris blocks drop to the bottom, Ben.
Anderson's just closed it.
And we're off.
Now
we've got a race.
Okay, so they are moving quick. Marmot E looks like it's taken first, although they're moving up hand in hand.
Marmot E, Selenium, and Gator Wings are neck and neck. Erebus and Anderson's look like they're falling to the back of the pack, Ben.
Marmot E, Selenium, and Gator Wings looks like they're in a dead heat right now for first place, and they're not stopping.
Ben, over on the right side of the screen here, we can see Anderson's is gingerly adding additional wireless applications to their flows, but unfortunately, I think that's left them at the bottom of the pack, Ben.
Gatorways has just eked out Selenium and Marmot E for first place, and they're still moving quick for that finish line.
Ben, we've got over 2 minutes since we last tripped that incumbent's threshold. These teams have really figured out how to protect that passive incumbent.
Yeah, I think they've learned how to avoid it and how to co-occupy spectrum with it. Gatorwings starting to put a gap between them and Selenium. I think they're going to hit it.
Whoa!
They did.
All right, Gator Wings. Surviving through 2 eliminations, taking first place in our first match.
All right, let's review the leaderboard standings. Match 1 point so far, Gator Wings with 10, Xylenium with 8, Marmot E 7, Erebus 6, and Anderson's 5. And now to the leaderboard, same scores, 10, 8, 7, 6, and 5.
All right, so we've got 3 more matches here for these teams to score points and jockey their way to that top place position, Grant. And with that, I think it's time for our second match in the finale. Now, in this match, again, we'll see our teams show down in the alleys of Austin. But this time, there's a twist. We're going to see how well our SC2 radios can stack up against LTE. So we ran LTE in Coliseum on the very same hardware that our competitors use. We gave LTE its own swim lane, and after 3 minutes, it was able to score roughly 15,000 points. For this match, we've set the finish line at 15,000 points. If any of our competitors reach that finish line before the 3-minute mark, we will have witnessed that team outperforming LTE while collaboratively sharing Spectrum, Ben.
I hope they're able to do it.
I mean, me too. All right, guys, it's your time to shine.
Craig, can you pull up the match? All right, Paul, you ready?
I'm going to take one deep breath, and now I'm ready.
Go. All right, getting situated, and
now we've got things going.
They're off.
Go.
Okay.
All right, all teams starting to drop applications down and score points right off the bat. And there we go, Zelenium, last man over the line. Zelenium actually the one struggling in this particular match, Ben, to figure out how to get over that ensemble bonus line.
Craig, can you cycle us through the teams in the Spectrum?
It's hard to see where Zelenium is right now.
Erebus.
Oh.
Whoa, they've gone into Hulk mode.
Zelenium clearly in Hulk mode. They're up to 72 points per second here, Ben.
All right, Zelenium's Hulk sort of breaking through walls here, climbing up.
All right, we're now into stage 2. We're looking to see a team hit that point value before the 3-minute mark.
Marmot E making a breakaway, Paul.
Marmot E.
Marmot E might actually
in a race
hit the
by
finish
themselves,
line.
Ben.
I think they're going to do it. They already.
300.
Paul, they
Whoa.
crushed it.
I'm going to be honest. I didn't know there were 380 points that could be scored in that match, Ben.
They hit that about halfway through stage 2.
Wow, Ben. They really put the pedal to the metal there. Grant, why don't we get a leaderboard update?
Wow, that was incredible. So we're 2 matches in. Let's review the match 2 points. Marmot E scoring 10 points that round. Gator Wings 8, Anderson 7, Erebus 6, and Xylenium 5, which brings us to our totals.
Oh.
Gator Wings at 18, Marmot E at 17, Xylenium 13, and Andersons and Erebus both at 12. And this takes us to match number 3.
Grant, we've got ties at the bottom, and we've got only a point separating our top 2 teams. There's 2 matches left, still anybody's game. Now it's time to revisit the trash compactor. But now for our final round, to make things fair, we've taken all of our teams and we've evenly distributed them across the 5 alleys. Now, we saw, Ben, Team Anderson's really struggle in that match we highlighted before with the collaboration bubbles. It'll be really interesting to see how they actually survive this mashed up version of this scenario, Ben.
Yeah. Craig, let's pull it up. All right. Let's roll it.
Okay. And once we hit the 15-second mark, they'll be off to the races, and here they go.
Here we go.
All right, Ben, right out of the gate, we've got all the teams making huge application deliveries.
And bonus. And, Paul, it looks like they're all scoring pretty well together.
Yeah, Ben, I'm seeing great scores here from all of the teams. Marmot E ahead. No, it actually looks like Gator Wings scoring. Man, Gator Wings and Marmot E scoring about the same number of points right now.
Well,
the other 3
I think
teams
they're actually
struggling to catch them.
I think they're actually outperforming the knockout round scenario here. They're
all right.
doing really well.
Well,
Ben,
so now
we've narrowed it.
Ben, we're down to the final 5. We expect the best out of the final 5 here. And
whoa, okay, we see teams accelerating in points.
Point values are doubled. Teams are going to accelerate towards that bonus line here, Ben.
Marmot E, Gator Wings, and Anderson's all moving up quickly.
Oh, Ben, it looks like Marmot E is steadily pulling ahead of the pack, but Gator Wings and Anderson's nipping at their heels, Ben.
Paul Zelenium is racing to catch up to Erebus here.
Marmot E scoring about 30 points more every second.
They just stopped as they crossed into stage 3.
Last stage here. Point values tripled.
Whoa,
and it's a tear.
Anderson's just breeding Gator Wings for seconds.
Whoa, Marmot E! Woo! I saw a very triumphant raising of the Marmot there at the end of that match, Ben. Grant, let's get an update here on our leaderboard after the end of this third match.
Third of 4 matches. So at this round, we've got Marmony scoring 10, Anderson's 8, Gatorwings 7, Xylenium 6, and Erebus at 5, which brings our totals to Marmony with 27, Gatorwings 25, Anderson's 20, Xylenium 19, and Erebus at 17.
All right, so we've got really tight races here as we head to the final match, Grant. We've got only 2 points separating our top 2 teams, Marmony and Gatorwings. Xylenium and Anderson's, as well as Erebus, actually in a really tight contention here in those bottom 3 places. This is going to be an exciting final match. I see lots of teams, I think, over there are probably going to need oxygen masks as soon as we're done with this match. Don't worry, we have EMTs standing by, folks. Okay, so now we're ready for our 4th and final match. Here we're going to revisit Wildfire. Now in this version, we've made it equal across all teams. That is, each team has an equal opportunity to score high priority points. Ben?
Now, well, Paul, we saw Marmot E clearly know how to do this in the elimination round.
Yeah, I mean, this was Marmot E to a T. They scored 200,000 points more than anyone else in this round. They're already at the top of the leaderboard. We'll have to see how this plays out for them, Ben.
All right, Craig, let's pull it up. Here we go.
I'm going to need the oxygen mask when we're done, honestly.
Remember to put the mask on next to the people around you before fixing your own.
I'll take care of Craig first for you.
Okay.
All right, Craig.
There we go, Craig. Let's roll it.
All right. Again, we've got a 3-stage scenario. Point values going 1, 2x, and 3x. We're starting to see those teams form up and their UAVs fly out.
All right, we've got the first formation starting.
Ben, I've got priority applications from Erebus, from Xylenium, from Gatorwings. Nothing. Oh, Marmot E's got some now. Anderson's has yet to score any priority points here.
It looks like everyone currently moving up in lockstep.
Hanging.
Oh, there we go. We're in bonus.
Now we're over the bonus line. Gatorwings, though, putting the pedal to the metal. We got 2 of their 3 priority flows achieved. Only 1 priority flow from Marmot E so far, Ben.
Paul, Gatorwings is using this opportunity to start to pull away from the rest of the pack. Same with Xylenium. Xylenium starting to move up.
There we go. Xylenium, big point scores here, Ben. It looks like those 2 teams pulling well ahead of the pack at this point.
Gatorwings and Xylenium both, it just slowed down a little bit.
Yeah, Ben, we've got Team Anderson's here. Looks like they're struggling to actually get... Okay, we've got 2 priority flows now from Anderson's. This is their chance to start to scream back up the leaderboard.
Paul, Marmot E and Erebus both starting to close the gap with Xylenium.
Ben, I'm not sure what happened as we flew over Team Xylenium there, but all the points kind of dropped back when we hit that zone. All right, we're now headed over top of Gatorwings, and we've got Xylenium out to a handy lead here of 143 points per second.
Paul, it looks like Erebus is about to catch Marmot E, and they do, displacing them and taking 3rd place.
Whoa, and there goes Xylenium displacing
Gatorwings.
Ben, all right, it looks like we're about to hit stage 2. Point values are doubled here in stage 2, Ben. We've got more points to score in our priority flows. Let's see how these teams do.
All right, the air formation is about to make
Gatorwings is taking it back from Xylenium. All right, Marmot E.
As they come over, here's where they can close that high priority big flow.
Ben, here is Anderson's over the threshold here.
Gatorwings is accelerating.
Oh my goodness, we've got Gatorwings pulling well ahead of the pack. Xylenium and Marmot E just can't catch up to their point totals, Ben.
Yeah, Marmot E and Erebus look like they're moving up in lockstep. Xylenium moving up, although there's not much movement right now, Paul.
Ben, we've got Anderson's below the bonus line right now. That's locked everyone's scores.
Whoa,
now,
there we go. They're
over the bonus line. Point values unlocked.
There's not a lot of distance between Gatorwings and the finish line, Paul.
No, I think they're closing in on it, Ben. Oh.
I think they're going to hit it. And they've got it.
Oh, and there we got it.
Xylenium taking 2nd. Marmot E taking 3rd.
Wow. Now, I'm sure the astute audience member has remembered what the scores were, but Grant, I've already forgotten, so I need to see our final leaderboard.
All right, and here we have winning teams. Gatorwings with 35, Marmot E 34, Xylenium 27, with Anderson's at 25 and Erebus at 23. And now, to help award the prizes to our winning teams, it's my pleasure to welcome DARPA Director, Dr. Stephen Walker. And at this time, I'd like to invite our winners to the stage. Starting with our third place winning team, who will now receive the $750,000 prize.
Welcome to the stage. Come on up, guys. This is apparently your graduation day. You've graduated from the School of Spectrum Hard Knocks.
Congratulations, in third place.
Congratulations.
Team Xylenium.
Thanks, guys. Great job.
Congratulations. Come back over here.
Here, hop in right between us. One of you holds this beautiful. Good. All right. Thanks, guys. Great job.
All right. And now, I'd like to bring up our second place team, who have earned the $1 million prize. Congratulations in second place, Team Marmot E.
Congratulations, Peter. Great job, guys.
Great job, guys.
Great job.
Congratulations.
Great job.
You all did fantastic.
Great work. That was fantastic.
All right. Why don't we'll make some room here for you guys in the middle. Who wants to hold the coveted SC2 trophy? All right, guys.
Fantastic.
Thanks.
Great work. All right, guys, come on up. Make your way to the stage. Let's do this. And finally, for the grand prize of $2 million, the Spectrum Collaboration Challenge champions, the award goes to Gator Wing.
Great job, guys. Congratulations, guys.
Great work.
Congratulations. Great job.
Fantastic. You pulled it out. Fantastic.
All right, let's make some way for Team Gator Wings here in the middle.
There you go.
John or Tan, who wants to hold the coveted trophy? All right, here you go, Tan. Great job, guys.
Great work, guys. Fantastic. Congratulations to all of our winners.
Come on, guys.
Come on back over.
Welcome. Everybody, today we challenged these teams, but we saw them able to provide us stable service in spite of sharing spectrum. We saw their ability to reuse spectrum. We saw their ability to dynamically prioritize. We saw them handling surges, and we saw them operating in congested environments. And then we threw one more thing at them, and we saw their ability to protect an incumbent. Folks, today we've witnessed the dawn of a new frontier in wireless. For the first time, we've seen AI-enabled radios collaborating autonomously, unlocking the true potential of the RF spectrum. Our competitors packed 3.5 times more wireless signals into the spectrum than we're capable of today. Our teams outperformed static allocations and demonstrated greater performance than current wireless standards like LTE. They collaboratively managed interference to legacy users. And I think the paradigm of collaborative AI in wireless is here to stay and will propel us from spectrum scarcity to spectrum abundance.
Thank you, Paul. That brings us to the end of our program. It's been an honor for me to witness DARPA doing what DARPA does best, driving innovation forward and inspiring these competitors to create new technologies that will eventually benefit us all. On behalf of DARPA and all our competitors here at the Spectrum Collaboration Challenge, we'd like to thank you for joining us in this brave new world.